I promise to upload the slides earlier than I did, but circumstances, issues, and all. But good, I was able to upload it last night, and so I believe all of you have seen it. I believe all of you have seen it. If you
Yes.
haven't seen it, then you are informed that chapter 2, chapter 3 have all been uploaded. So what I'm going to teach today, at least for chapter 3, is with you already. Okay, so even without sharing the screen, you can follow. All right. I hope most of you have your laptop, so you connect the WhatsApp to it, and then you get it on your laptop, so you can follow even as I proceed. As I keep saying, the slides are about 85-90% what is in the book. All right. So if you get the slides, you have invariably gotten the book. Okay. So we start our lesson in the name of the Father, the Son, and the Holy Spirit. Amen. Right. Um, Last week we talked about errors in surveying, for example, errors in taping, in chaining. That was the last thing we did. Um, we came across errors like incorrect length, proportional errors, and then constant errors. We also saw um, something like sag correction. Okay, if you remember, we also did talk about tension correction and all those. Those were the last things we did last week. We also mentioned temperature correction. All of them are with you now. So you have the whole of the unit 2. I'm going to start from unit 3. I've started chapter 3, unit 3, chapter 3, they are the same. Okay, so here we go. Um, Chapter 3 or unit 3 is methods in surveying. Methods in surveying. I've told you that this course is only giving you the basic knowledge in surveying. It is just like those who have learned or are learning how to sew. Today, nobody has time to wind the wrist in sewing, the old type of sewing. But once you enter, you will be made to go through it. Because now we have supersonic machines, what they call industrial machines, sewing machines. All of them are using electricity. And so nobody winds the wrist in sewing. Okay. But a fresher will have to go through it. The same way, there are sophisticated gadgets today for surveying. But once you are starting, you have to go through the fundamentals, the basics, the old ways to know the various principles. That is why we are taking this journey. And so, under the methods in surveying, we are looking at one of the most basic methods known as um, chain surveying. Chain surveying. There is a diagram, chapter 1. I referred to it shortly. I told you that when we get to chapter 3, I'll tie chapter 3 with that diagram because that diagram is a summary of most of the things under chapter 3. All right, especially the first part. All right, from according to my page 43 all the way to 51 and so on. All those places are under chain surveying. So I'll give you the what I call the theory as we have them on the slides. And then we'll go back to chapter 1 and pick that diagram and see how the theory we are going to take here reflects on that diagram. When you get there, I'll tell you the exact slide for that one. So we are on chain surveying. I mentioned earlier when we were talking about um, the classification of surveying. I mentioned chain surveying. I told you that one fundamental definition of chain surveying is a method of surveying that involves the taking of only linear measurement. That's all. Linear, no curvilinear, no angular measurement. You are taking straight measurements. That is what surveying is about. Chain surveying, I mean. So on the field, that is what you are expected to do because the instruments you are going to use to undertake this type of surveying are instruments that you cannot bend. The chain is made up of links and rings. You have seen the photo now of the chain. You can't bend it. The tape cannot be bent. And so, if you are going to do chain surveying, then you are going to undertake surveying involving the measurement of linear distances. So, only linear measurements are taken in the field. Now, after that, you are not done. You bring it to the house. If you prepared for the field, you also do the second thing on the field. You can do it there. Maybe you have a shed where you can sit and do it. But calculation is done in the office. You have to do calculation. Somebody will ask, what type of calculation is that? You see, you are going to measure distances. Some of them 20 meters, others 30 meters, others 40. Some are even as long as 100 feet. There is no paper under the sun that can accommodate 100 feet. There's no paper. Meanwhile, we are also not doing large format printing, the large billboards that they put on heavy notice boards. We are not doing that type. Ours is the A4 type, maximum A3. And so you will not get a paper as big as 20 meters or 100 feet. Therefore, you have to go and do calculation. Calculation here involves adopting a scale, a common scale, to reduce your distances into plottable form. That is what the calculation is about. So imagine you have 20 meters, all right, as your distance measured. Maybe from ranging pole A to ranging pole B or station A to station B. There's no paper. So what scale can you choose so that your 20 meters can be plotted easily on a sheet of paper? So you choose a scale such as, okay, let 1 centimeter represent, let's say, 1 meter. And even that one cry will still be long. So if you choose such a scale, it means that if it is 20 meters, you are going to plot 20 centimeters because every 1 meter will be represented with 1 centimeter. So if it is 20 meters, then you have 20 centimeters. That will still be too long for a normal A4 exercise book type of thing. And so you can increase it by saying that let 1 centimeter on paper represent 2 meters on the ground. So your scale will be 1 centimeter to 2 meters. You write it. Okay. So it means that if you have 20 meters, you are going to have 10 centimeters on paper. That's how it is. I believe 10 centimeters here. There are a number of papers that can accommodate. You can also choose decimals. But you see, we always want to play safe. You don't want to bother our heads with all these decimals. You can say 1.5 meters. Let's say 1 centimeter to 1.5 meters. That is also allowed. But as I said, decimals are difficult to work with. So usually we prefer the whole numbers. Okay, so that is the type of calculation you will do in the office. After choosing this scale, all other things that you do, because you will start by doing your what you call your outline, your map, the shape. Then you will fill the shape. That is the insertion. So you went to the field. There was a heap of sand somewhere. There was a river somewhere. Okay. Um, there was a footpath somewhere. There was even a piece of road cutting through. All right. all of those ones will have to be shown. And that is when you come in to fill it. So you do your outline. And that is the plotting version. So plotting is done also in the office. Remember, as soon as you get to calculation and plotting, you have moved away, all right? You have moved away from surveying and you will then be in cartography. Surveying is only the taking of the measurements, that's all. So anything that you do afterwards stands for cartography. So the calculation I mentioned, the plotting is the cartography side. That's why we have it as surveying and cartography. More on that, as I mentioned, we do not take any angular measurement. Angles are not measured because your chain is not a type of instrument that can be used to measure angles. Your tape and all of them. Okay. Now, one thing you will do, as I mentioned earlier, is called triangulation. You will do triangulation. And here, as I told you last week, you are building a skeleton or a framework of triangles which are connected. So one triangle will be connected to the other. I mentioned that in chain surveying, even if your area is a regular shaped one, you still have to triangulate. And the reason for doing the triangulation, which we shall see very soon, and I believe you have seen it, the reason for doing the triangulation is the insertion, all right? The fixing of what you call offset. There's something you call offset. You'll get there, I'll explain. You have to fix the offset. And the offsets might be so close to survey lines. And the only way to do that will be the triangulation. The offsets, I've already even mentioned them. If you find a heap of sand somewhere, it is an offset. If you find road somewhere, it is an offset. If there's a footpath, that we have to show is an offset. We include all these just to give us further proof that indeed the map stands for a particular location. If you do the skeleton, all right, the skeleton without putting anything in there, then you are not talking about any particular place. It can stand for any place. But once you show these rules, sometimes you can even mention the direction of the road. Maybe road from this place to that place. Once you mention it, then you are giving indication as to where the plot lies or where the land lies. Either than that, when I pick it, it is meaningless. Okay. And so that is why we do triangulation. All right. Now, there's something called stations. Stations. If you are triangulating, building a network of triangles, every corner of the triangle is represented with something we call ranging pole. Last week, I showed you that the ranging pole is more or less like the javelin. Okay, so you are building a triangle, three-sided figure. Okay, so you need three ranging poles. Let's not forget, when going to the field, you need about 10 of them, about 10 ranging poles for any type of field work. So three of them will be in use at any point in time. Three of them will be in use. And these ones are going to be used to mark the stations. The angles, the corners of the triangle will be known as the stations. And the stations are marked with the ranging pole. They are marked with the ranging pole. Okay. So before you start the actual work on the field, after you have ascertained that everything is okay, you have given your team, the survey team, the briefing, you have assembled all your instruments, you have examined them. All these are things you do before you set up. You have examined them. And some of these things, you will not find them here, but they will appear in your objectives. All right. So you assemble your team, you brief them, and a typical chain survey team is made up of three people. And the three people are the leader, all right, the follower, and the booker. Booker. These are the three people. You can add some more, but in the main, these are the three people that you will need. They will constitute the team. The follower and the booker are not necessarily surveyors. That is why you have to give them briefing. You may need some other people to help you because of the instruments involved, to carry the pole, to carry this and that, as you shall see very soon. Okay. Now you are ready. Team is ready. Instruments are ready. Okay. But before you enter the field, there's something called reconnaissance survey. That is the first stage of any surveying. As you move on, you hear the stages of surveying. Reconnaissance is also known as preliminary survey. Reconnaissance is also known as preliminary survey. That is when you go to familiarize yourself on the field to know. After all, it is somebody's work you're going to do for a fee. You don't know where the plot is. So for a start, you have to go following the person, for the person to go and show you the boundaries and the location. And that is the reconnaissance survey. When you are there, you make a mental note of the area. Okay. You look at how you're going to triangulate. You look at everything. Okay. You look at everything as part of the reconnaissance survey. I'll tell you more about the reconnaissance survey as we journey on. So that is it. Then, if it is change surveying, then you're going to do it over a small area with few details. So something like somebody's cocoa farm, not a plantation, cocoa farm. Or if you can extend it, let's say a plantation, maybe a market. All right. Those of you know my area, Jonas Market, Bekwai Market, Bantima Market, and so on. School compound. You can also do change surveying there. All right. So I told you earlier that change surveying is done on a small scale. When you hear small plane, we're talking about a small area. And that will mean that that area will be devoid of too many details. You don't have too many of the things there. It may be only some road there, some buildings, one or two, three, four, five, not too many obstacles. And so you will not struggle because it is a Herculean task carrying the chain, dragging it here and there, triangulating. So if the area is vast, if it has a number of details, then you're going to spend quite some time getting the work done. All right. Meanwhile, you are not supposed, within 1 week, your work should be over. Everything should be over for chain surveying. So that is that. Let's talk about the instruments, the core instruments that you need. We need the chain or the tape. They have something in common. The chain and the tape have something in common. They are all used for taking measurement. But the distinction is that, and you have to pay attention because some of these things that I say may not be explicitly stated in the slide. So I said the chain is used to take long measurements. The tape is for shorter measurements. And mainly the tape is for taking offset. Offset is any object which must be fixed onto the new outline. And when it is part of the note, when you get there, I'll tell you what it is. So we have the chain, we have the tape. Then the ranging pole, the ranging pole or the ranging rod that I keep mentioning is here. You have seen the photo. Those of you have taken time to go through the slides. You have seen the ranging pole. It looks more like the javelin. When you get there, I'll describe it. We have something you call arrows, which is mainly metallic. I'll explain it. We have pegs and then we have cross staff. These are the main instruments. But I tell you, you also have to get writing instruments, pen, pencil, notepad. As you move on, there's something you call field notebook. The diagram that I said I'll explain is a typical page in a field notebook. So that is the introductory part of this one. Let's move on to still talk about the methods. This time we are looking at the instruments. As for the chain, we have seen it already. We have described it. That is why it is not here. Okay. So the first one is the ranging pole. The ranging pole. Oh, the name didn't come. Please, those who are what happened? Those who are watching or seeing the white and red pool, that is the ranging pool I'm talking about. I'm surprised the name is not here. Okay, now I've told you. And this by law is supposed to be 10 feet, 10 feet long, all right, and 1.5 inches in diameter. So it's a round object, round, all right, and it is wooden, painted with alternate bands of either red and white or black and white. Okay, that's how it is painted. So how you see it, that's how it's supposed to be painted. We use black also, but in the main these days we are hooking on more to the red. And the question is why red, especially at the top of it? Why red? Anybody? Let me see the people I have here. Mm-hmm. Why do you use red and not any other color? Red and white. Mm-hmm.
For easy identification.
For easy what?
Identification.
Okay, that's correct. On a scale of 10, I'll give you 8. You see, you use red because if you use black in the bush, for example, which can happen because you may also go to the bush. You have green, deep green colors there, the leaves. They may mix up with the black. If you are standing far away from the pool, you may struggle to see it. The white may mix up also with the sky or the horizon. But if it is red, it is easily identified, especially the tip of the pool, especially the tip. Now, another thing about the ranging pool is that it has a pointed tip. So those who have observed what I'll give you carefully, this is common. If you go online, you will see it. You see that the tip is pointed, mainly mostly metallic. You put metal there. The improvised one that I used to have here, and I still have it, is a nail, a nailed metal. We have nailed the metal. Why? Because sometimes the ground may be so hard. So if it is just the wood, you end up breaking it. But if it is metallic, it is capable of penetrating into the soil. This is what we use to mark our stations, ranging pole. This is what we use to do the triangulation, ranging pole. Okay. Then the second one here is the arrow. Arrow. As for the arrow, it is strictly metallic. It is metallic. And how you see it in the picture on the slide is how it looks, the arrows. You have to carry no less than 10 to the field, just like the ranging pole. Okay, so it is steel wire, 15 inches long, pointed at the tip, because this one too, you are going to plant it. Hmm? You are going to hammer it to the ground. So it should be, uh, pointed at the tip. Now there's a loop. The loop is a round thing at the tip also, at the other end, the handle. There's a loop there. Okay. Now this loop is for handling, for you to handle it and be able to plant it into the ground. It is also for tying rag. So that thing there that you see hanging around the loop is a rag, a piece of rag. Question is, why the rag? See, the metal, this one there is not painted in any color, it can be anything. But the rag should be there and it should be a colored rag, mostly red. It is short. And so if you plant it in the bush, you may not be able to see it. Sometimes it can even fall off and you struggle to locate it because like the iron rod, those of you have been building, the quarter rod, for example, that is normally what you use, the improvised one. It comes in something close to dark color. On the field, in the bush, there will be pieces of wood, that dead wood, I mean, that may appear dark. So if it falls over, it will mix up with those ones. Therefore, we have to tie the rag, which is color, so that easily we can identify it when it falls off. You see, this is not the point I just made is not part of the note, but I've told you. So take note of it. It is colored rag. How you use the arrow is the last sentence. They are used for making chain lengths on the ground. They are used for making chain length. And what is the chain length? I told you the chain is 100 feet, if you remember. Maybe you are triangulating a distance beyond 100 feet. Some of them can even be 300, 400 feet. That means that you are going to stretch the chain 2 times, 3 times, 4 times, as the case may be. Now, how would you know ordinarily where you ended? Because once you have triangulated, there should not be any intervening object between one station and the other. And one thing which you may not find on the note is that the stations should be intervisible. Meaning, if I stand at station A, I should be able to see station B. If I stand at station B, I should see station C. If I stand at station C, I should see station A in that order. You understand? So they should be intervisible. Therefore, after stretching your chain, all right, you are not just going to cut any wood at all and mark the end of that chain when you stretch it, that is the 100 feet. No way. What you use to mark the end of that stretch of the chain is the arrow. So you use the arrow for making chain lengths on the ground. You stretch it 100 feet straight, and you have to walk over to ensure that it is fully stretched. All right. So wherever it will get to on your chain line, on your survey line, you plant one of the arrows there. We anticipate that no no chain length or no measurement will be more than the 10 arrows. So if you carry 10, at least it will do. So use it to mark the end of the chain length. That is the ranging the arrow. Moving on, we have what you call um, peg. What are the names? They were part of, okay, so those things there, they are wooden. We call them pegs. 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 Uh-huh. They are wooden in nature, all right, and they come in something square or it can be anything. All right. Now, the same way we use the arrow, you can also use the peg. Therefore, if you don't have the metallic one, you can use the peg. But on the other hand, too, we can use the peg to fix stations. So just like the ranging pole, if you don't have the ranging pole, at least you can improvise using the peg. All right, so it will serve some dual purposes here. Then the one on your left, like a loom, is it a loom? The one the kente weavers use to, wind their kente. It is known as cross staff. Cross staff. It is made of wood also. It has, should I say, a leg. It has a leg. That leg should be pointed. But all the instruments are coming with pointed tips. That leg should have a pointed tip because you will also plant it into the ground. Now look at how it is made. You have two bars, but the two bars are crossing each other. All right, giving you 4 quadrants. They are crossing each other, giving you 4 quadrants. This one is supposed to be special. Each of the quadrants should give you a perfect square. So if you're improvising, you go to the carpenter, all right, after crossing it for you this way, make sure he puts the square there. Carpenters have a square, all right, to ensure that each of the quadrants is a perfect square. You can improvise this one. And then there is an upright, 4 of them on each of the arms. So after crossing the 2 bars, you have 4 arms. And the 4 arms are supposed to have the slits. We call them slits. Those things that are standing, we call them slits. As you move on, I'll tell you how what you use the cross staff for. In fact, we use the cross staff for taking offset at right angles, at 90 degrees. That is why I'm saying that each of the quadrants should be exactly 90 degrees. What you see in the note as 900 is not 900. It's supposed to be 90 degrees. So to correct it, or to having. Sorry for the brief interruption. Somebody got through. Okay. So I was correcting something that the 900 you see on the right hand side of the description of the cross tab, it's not 900. It's supposed to be 90 degrees. Okay. So we use it to take measurements at 90 degrees. When we get there, I'll tell you how it goes. So it is one of the instruments known as cross staff. There are different types, but this is the most basic. We have the cross staves, the open, the French type, and then the adjustable type. That is the most basic. We are now on terminologies in chain survey, terms used in chain survey. We have main stations. Main stations. As the name implies, it is the end of the principal survey lines, which comprises the skeleton system. If you go to the next slide, you see a diagram there. And that diagram contains all these names. All right. So let me explain so that when I get there, you can refer to. Then we have subsidiary or tie station. It's an intermediate station, a station that is, you will see proper on the. Then we have the baseline. That is the longest line of the survey lines, the longest of them all. Okay, because that is where after, let's say, taking your first triangle, the next one will also be built on that line also. So we have baseline, we have check lines, lines that are used to prove what we have done, proof lines. Okay, and then the offset that I mentioned, offset, the offset that I mentioned. Let's say you have gone to survey a place, school field, market, school compound. So you know the dimensions. You know the dimensions. But you realize that the area you want to survey wasn't, uh, um, should I say, a rectilinear area. In other words, it is not having a regular shape. Maybe it curves somewhere. Okay, there's a curve somewhere, there's a square somewhere like that, or even it can even be a round shape. Something doesn't mean you will not survey. You survey. You build your triangles close to the corners and leave the curves. You leave the curves. You understand? If you do a circle now, you can have a straight line joining 2 points on the circle to the edge of the circle. Okay, then you can have another one cutting through almost the center to the next point on the circle. Then another one will also come through. So that will be your main triangle. You have a triangle. Now, what happens to the other sides where we have the curves? Okay, when you are unable to triangulate further, because after building the main triangle in the middle, when you're unable to triangulate further, because those curves, you have to still triangulate. And so you have main triangle and subsidiary triangles. If you get to a point, you cannot build any more triangles. The curve will still be there. that curve will be treated as an offset. Okay, so an offset is a distance measured to locate the position of a feature or an object. So after you have gotten everything, let's say what the enquiry it was a regular shape something, but there are objects inside the area you surveyed. Okay, so you have to fix those objects. Maybe there's a road that cuts through, or at one end of your area, there's a footpath. Okay, there's a very big tree standing somewhere. There is a rock, huge one, sitting down in the middle. There's even a pool of water, something like a lake. There can even be a river passing through it. All these are offsets. So you measure and locate them in your new map, the map that you are going to draw, or the plan that you are going to want, you are going to have. That measurement that you take from the survey line to these objects so that you can get their location is what we refer to as offset. When you go to that diagram that I mentioned, you will see the offsets over there. Okay, so we have two types of the offsets. We have ones that are taken as perpendicular offset, and there you will need your cross staff. You will need it cross staff. Yes, you need the cross staff. Maybe as you move, when you get to that diagram, I'll explain. I'll demonstrate how to use it. I'll let you practice how to use the cross staff. Then we have the oblique offset. You will see one also on that diagram where you are taking offset, all right, but you are not taking it at 90 degrees, but rather at an oblique angle, all right. So these are the two types of offset. Now, I mentioned some terms associated with surveying or terminologies in change survey. Okay, so we have the terms showcased here. I mentioned baseline. You've seen the baseline there. I mentioned the tie. You've seen the tie line there. I mentioned check line. Okay, the check line is also there. All right, the S1, S2 lines, they are the check lines. The tie is the T1, T2. And then the main survey line, which I also mentioned, are those that are there. Okay, so we have main survey lines. We have 4 of them in this diagram. That is A, B, C, D. They constitute the main survey lines. Now, on this diagram, which looks closed, close to what I'll be explaining, you see that there's something circular with some dotted lines inside. That may be a pool of water. Okay, this is what we refer to as offset. You also see road there. That is an offset. You also see some 2 squares or rectangles on your right. That is also an offset. You also see a rectangle just below the check line. That is an offset also. There's another one down the baseline where you have written baseline. That's another offset. Even on top of the tie, where we have written tie, you see another one there. All these are offset. Now let me use the one on your right, for example. There are 2 of them. Okay, so I'm using the first one. You have done your survey line, the main one, you have gotten it straight. This was a regular shaped land. And so your lines are straight. But close to this line or close to this plot, there is a box. Let's assume it is a building. It is not part of what you're surveying, but let's assume it is Papa Kwaju's building. The second one belongs to Horali. The second one belongs to Horali. These are their buildings. Now you might say that, oh, why must I worry myself fixing this building or showing this building in the map that I'm going to sketch? All right. You have to worry yourself because if you don't show these 2 buildings, then your map will not represent any particular location. It is Papa Kojo's building that gives you the location. That tells you that indeed the map you have drawn is coming from measurements you took from a plot close to Papa Kwesi's or Papa Kojo's building, or Holali's building, or Noah's building, or Azima, if you like. Okay, and so on. So you fix it. Now, this is where the cross tab comes in. This is where the cross tab comes in. For such a regular shape, you take two measurements and you have fixed it already. First, you take one from the top, one from the down. And how are you going to take it? You are going to take a measurement that is standing at 90 degrees from line BC. Okay, so you start measuring from line BC. Let's say the top, close to the edge. All right, you measure from that point. Now, the tape or the chain that you use to take that measurement must lie on the ground standing at 90 degrees. So how do you get your 90 degrees? And that is where the cross staff comes in. That is where the cross staff comes in. So you bring your cross staff, okay, you fix it on line BC. It has a leg which is pointed. So you plant it on line BC. That is close to the edge of the box. All right. After you have planted it, you are now going to swing the cross staff. You are swinging it such that two arms, it has four arms. Two of the arms, which are opposite, will be facing the edge of the building, the edge. Okay. Two of the cross arms will be facing the edge of the building. Now, this is what you do. You squat. You see, there was a slit standing on top there. Those of you followed. So you squat outside into the main area that is close to the road, for example. You squat there and then look through the two things that were standing. Look through one of them. And as soon as you look through one of them, your eye must take you to the other. So now you'll be looking through the two at the same time. After looking through the two, you should see the edge of the building through the two slits. You should see the edge. Yeah, Holali.
Good evening, sir.
You can hear.
I seem to be lost. Please, are you sharing a screen?
Oh. Can you hear me, please?
No, please.
You can't hear me.
Yes, sir.
Can hear you.
No, not the previous statement, but as I time I asked the question.
Yeah, Nana.
Yeah. Who said you wanted to ask a question?
Sir, this is me, Felix.
Okay, Felix, let's go.
So I seem to be lost, so I don't know whether there is. I joined a class late, so I seem to be lost whether there is a screen to be shared or.
Well, I see. I can only share the screen when I am I'm using the phone. I must say. So there's no screen. Besides, I've given you the slides. Have I not?
Yes, the ones I have, I flipped through it. I seem to be lost. That is why I'm asking. If
You can't follow.
yes, sir.
Okay, the one that I gave you, go to slide 36. You see, it was chapter 2 and chapter. You see, when you're late, that's what happens. Chapter 2 and chapter 3. So I'm now on slide 36. Oh, yeah, slide 36. Yeah.
Okay.
Okay. Okay. So let's go.
All right, thank you, sir.
So I'm explaining the diagram there
Okay, sir.
and how
Thank you.
to or do the offset. So you have already planted your cross staff in line BC. You see, the line you see there is not a line you are going to construct on the field. This is a line created by the ranging pool. We have station B and station C. Okay, so there's a pool where we have the triangle at B. There's another pool where we have the triangle at C. Okay, so the straight line with your eye that connects the two is the line you see there. So that line, those lines are not lines that are on the ground. Okay, so you plant your ranging pole between or in that imaginary line, if you like. Did I say your ranging pole? Your cross staff. Your, your cross staff must be planted in such a way that you will swing one of the arms. Okay, one arm, but eventually you get two. So two arms must be pointing at the corner of the building. Now, when they are pointing at the corner of the building, you will come and squat inside, close to the road, for example, and then you'll be looking through the slit. There's a slit. Those of you who watch the diagram or the cross staff, the slit, those four things that were standing. See, there are holes in each of them, and that is a slit. So you pass your eye through one of them, and it should take you to the other one because there are two of them that are opposite. It will take you to the other one. Now, when your eye is able to penetrate through the other one, then it should also be able to get you to the edge of the building. As soon as you're able to sight the edge of the building through the two slats, then your cross staff is now standing at 90 degrees. So what you do is that you start measuring from the cross staff. You see, it is planted down there. You lay your chain or your tape from the leg of the cross staff all the way to the corner of the building, and then you record the measurement. You come to the down part, the down corner, all right, and you do the same thing there. You plant your ranging pole and swing such that two arms will be pointing at the building. When two arms are pointing at the building, you should be able to sight. You should be able to sight the corner of the building by looking through the slit. And when that is done, surely your ranging pole is standing at 90 degrees, and you start laying the chain from the leg of the ranging pole to the corner of the building. So now you have 2 points, two measurements, one top, one down. These two measurements you have taken are what you refer to as offset. They are what you refer to as what? Offset. Sometimes the offset will be inside the area you surveyed, like the round things there. Okay, like the round things there. Okay, so the same way, this one, if you want to take offset, you are going to operate with line CD. All right, it is the closest line CD. So you take the offset from 2 points on the circle, and there you have the actual location of the circle. The same will go for the one under the check line, the rectangle there, and so on. So that is how to use the cross staff to take measurements at 90 degrees. As I told you, there are two pieces of wood, okay, the same length. Then you cross them. So that at the end of the day, you have 4 arms. That is how to use the cross staff. Right, let's move on to the next slide. We are now on slide 37, if you wouldn't mind. We are going to do proper surveying. Procedures in chain surveying. How do you proceed? How do you conduct your survey? You have done everything, you have done the briefing, you have assembled your instruments, and so how do you begin? I told you that the first stage in chain surveying is known as reconnaissance survey. Reconnaissance survey or preliminary survey. That is the first stage. Now, what do you do over here? As I told you, you are going to do this work for a fee. So the plot you have to even go and survey. You don't know where it is. You don't know the way leading to the land. Somebody must take you there. It is part of the reconnaissance. And when you are there, you are going to familiarize yourself with the area you are supposed to what? Survey. And how are you going to do the familiarization? You are going to check the boundaries carefully because the day you commence work, the landowner or the landlord may not be around. So you have to check the boundaries very well. Very, very well. You have to make a mental note of the area, the shape of it. In fact, the way leading to the place, you should make a mental note of it. It is part of the familiarization. You also inspect everything inside. You do inspection, everything. If there's a footpath, there's a road leading from town A to town B, and all of that, you inspect. Okay. After that, you also do rough sketch because you have to get a fair idea how your final map is going to look like. So you have to sketch it. That is when you have gone round and you have made a mental note. That should help you to do rough sketch. That one, you are just sketching it without passing through or going through the boundaries or going over the boundaries. You just sketch it. All right. And then during the reconnaissance, that is when you are also going to divide the area into triangles. By this, I'm not saying you are going to plant your ranging post. No way. You are going to use your mind's eye. Okay, here, I'll put one station here, I'll put one there. This one will be, okay, here, I can build one big triangle here, and then I'll build subsidiary ones. Okay, this place is a curve, so I'll triangulate this way, like that. You use your imagination to do the work. Okay, so that is the first stage, reconnaissance or preliminary survey. Then the second one is the actual survey. The actual survey. Now you know everything about the land, the plot. So you are now ready to go and survey. And what are you going to do? On the field, during the actual survey, one, you have to fix your stations. And what are the stations? I showed you what the stations are. The ABC that I showed you are your stations. They are your main stations. But you find that a station has been built. If you go back to the diagram, you find that a station was built, a triangle was built around A, B, and D. Another one was built around B, D, and C. You understand? So all of these will form your triangle. You see, this was a regular shape, but still the person triangulated. The person did triangulation. Okay, and he did that because of the offset, the root, the circle there, the rectangle, and all those shapes that he has to fix. That's why he did the triangulation, because the rule is that if you have to fix all these ones, the rectangle, the circle there, and all of them, the measurement that you take in order to be able to fix them shouldn't be too long, and therefore you need to triangulate so that some of the lines can get closer to those objects for you to be able to measure the lines. Okay, and so they are your main stations. You build this one, all right. At least your line AB there, you should be able to build it. That is why the note says that is the main survey line. You have to build your line AB, and then after you have built line AB, you should have your line C and your line D. This is a regular shape, so you can go in this manner. All right. So that is what you do in the actual survey. You fix your stations. Now the stations are fixed with ranging posts or ranging rods. So the ABCD that I showed you are not alphabets that have been written on the ground though. All those points are fixed with ranging poles. Okay. Then the main lines are selected and chaining is what? Initiated. How do we chain? How do you go about the chaining? How do we conduct our chaining? That is a question for the gods, but I'll try and answer it. How do we do that? Okay. If you go to the next slide, something about how it is done has been written, but let me take you through it, how it is done. You have built your triangle. For example, triangle ABD. That's your triangle. So you're going to survey. ABD have ranging poles. So this is what you do. You are using the chain. You start from A. You are measuring the main survey line. So the leader will hold one tip of the chain. That is one handle. The other day I told you the chain has two handles. So the leader will hold one handle of the chain. And that leader will be dragging. I'm telling you what each of the team members does. So. Okay, so this is what the leader does. The leader will hold one end of the chain because this you'll not find in the notes. And then you'll be dragging the chain. That's why the chain is resilient, very strong, because you're going to drag it either in the bush or wherever you are doing the work. You'll be dragging it, and the chain will be stretching gradually as he moves. Now, as he moves, he is focusing on, let's say, station B, because he's moving from A to B. So he's focusing on B. All right. So he's going in a straight line. Now, what work will the follower do? The follower will also hold the other end of the chain. And he will come and squat or stand. Squatting is okay because the chain must lie on the floor, on the ground. You come and squat at station A, where the leader started from, holding one tip, one handle of the chain. And so one work the follower will do will be to direct the leader. Because you, the follower, because you are squatting at A, you have the opportunity of seeing B. So if the leader is going off track, I've told you there are no lines. You are not going to use dry lines or any rope. No, you are using your eye to move. So as the leader moves, if he's going off track, off the line between AD, the follower will have to prompt him and direct him. Go left, kakra, right, kakra, okay, oh yeah, like that. Then he'll be guiding the leader. That's what the follower will be doing. So the leader will be dragging the chain until the chain is fully stretched. Now, when the chain is fully stretched, that is not the end. You lay the chain on the ground, leave it, and walk over, ensuring that the chain is fully stretched indeed. Because a part can fold without stretching. You may not know. So walk over it and check whether indeed everything has straightened and whether indeed your chain has been laid straight. When everything is okay, you mark the end of that chain with an arrow, as we mentioned earlier. That is one chain. That is one full length. Okay. Now, what happens next? Maybe like AB is so long, after 100 feet, you are not done. So you have to continue. So what will happen? The leader, the follower who was at A will now pick the chain, hold the tip, the handle, and move towards the arrow that has been planted, which is marking the end of the full stretch of the chain. So the follower will move there and go and squat over there. All right, you go and squat over there. We are not using ranging pole because between A and B, there should not be any intervening object. Any object that will prevent you from seeing the other hand. There's something called intervisibility. The two stations should be intervisible. Okay, so instead we use either the peg or the arrow. So the follower will now come and start at the arrow, and the leader will proceed, move on, getting to B, station B. You'll be going the same way, you'll be dragging all the way up to the point where the chain will be fully stretched. You will lay the chain on the ground, walk over it, ensure that the chain is fully stretched. If that is the case, you will put another arrow there as the next chain whole length. Okay. Now, if still he hasn't gotten to B, the follower will move away from the first arrow, will now come to the second arrow, and the process will continue until the leader gets to B. Now, let's assume you stretch the chain several times, about 6, 7, 8 times. Okay. And you have to finish the measurement, the full length, before you start recording. Whether you got 200 feet, 300, 500, 600, as the case may be, you have to finish before you start the recording, because somebody will have to record. Okay. Now, maybe you have gotten to the end of line AB. You are now at B. How would I know? How would somebody know that you did 5 stretches of the chain? How will I know? All that you do is to count, in answering this question, is to count the number of arrows that you planted on the way. So if you planted 4 arrows, it means you have done 400 feet. That is the total length of line AB. Then somebody will record. The person who will record is known as the booker. The booker. So he will record in the field notebook. We shall get there. That one is even more technical. Recording in the field notebook. But it is not just the normal writing that we do. Highly technical. You need to know it. So you record, and then that survey line will be over. That survey line will be over. Let's not forget, because, well, maybe I'll see it later. Every survey line is recorded on a fresh page, page 1. If you are measuring another survey, another line, let's say line BD, that one you record it on a fresh page. Line AD, you record that one too on a fresh page, like that. When you get to that diagram, I will explain. So that is how to carry out the survey, the actual survey. The actual survey, because it said main lines are selected and chaining is initiated. What I just said is how the chaining is done. And then the offsets are taken. I told you how to take offsets. And then booking is done. I'll repeat how to take the offset and so on. After the booking, the diagram will help us. So somebody will have to book, somebody will have to write. That is the actual survey. Any questions so far before you go to the third stage of your work? The third stage. How many people do I have? How many are you? Okay. Ima, your hand is up.
Yes, sir.
Okay.
Yes, sir. Please, my observation, I could see that line B to C is not that straight or perpendicular. It has.
Oh no, it's it's a photo I took. I didn't scan. I just took a shot.
Oh, okay. So, please then,
See
on the rear, can they have a straight line like in the form of square?
Yes. Once a straight line, yeah, you can. It's supposed to be a straight line, but because I use phone to take it, that is why it is looking like this. You understand? I didn't scan. I just.
Okay, sir. They've done a particular one at our place before, and I think they say 80 by 70 or so. It's not like a square. It has shifted like the way the drawing was. It's not a perfect
Okay.
square.
It depends. It depends the area the person was serving.
Okay.
It depends. Maybe the length is longer. Sometimes it can even be a round object, a round shape, something. So it depends where the person was working. Okay, so now let's go to the plotting. You are done with the field work. You are now back home. You are going to do your calculation. You are going to do your plotting. Okay, so plotting, this is where you're going to do your sketches. Or you are going to translate the sketches into what? Maps. Okay, you're going to have your area map, the map of the area you surveyed. As part of the plotting, you choose your scale. Those who are with me at the beginning, I told you, I described how the scale can be chosen. Okay, so I don't intend repeating it. You choose your scale and then you do your calculations. And what calculations are those? Dividing the distance you measured by the scale is the calculation. So I said, let's say it's 1 centimeter to 2 meters. You measured and got 20 meters. 20 meters. So what you do is that you divide 20 meters by 2 because your scale is 1 centimeter to 2 centimeters. And here you get 10. And that is what you use to sketch or to do your map. Okay, so that is the type of calculation you will do. You do some clerical work, secretarial work, such as putting figures together, titling it, and so on. Sometimes you even have to include the work and the name of the landlord. Okay, this is the elementary type. These days, the machines will do it for you quickly. Okay, so that is the secretarial work that you will do as part of your plotting. So the plotting stage is mainly where you're going to finish off the work. You are going to do the map. You are going to do the site plan, showing all the details you picked from the field. So these are the procedures and these are the stages in surveying. We move to the next slide, which talks about factors influencing the selection of survey station or survey lines. You went, the land is there big, or the area you are going to survey. So where you station your work or the areas, places you choose as your station, it's your own decision. At the end of the day, the landlord doesn't care. All he cares about is a plan ready for him. So where you will choose as your stations, he doesn't care. Okay. And so you are going to do your work. Now, the first thing you have to consider is that the survey stations should be mutually visible, as I described. Between line AB and each of the stations, there should not be anything blocking your view. There should not be something you call issues to do with intervisibility. Okay, the two poles should be intervisible. That's one thing you have to ensure. Then, your survey lines should be as small as possible. And how can you ensure that? You get to the field, you have to build a main triangle, big one. That ideally should cover more than half of the area you are going to survey. Big one. So that after surveying that one, what will be left will be something small. All right. Because the more you take the measurement, the more you accumulate errors. The fewer the measurement, the fewer the errors. So as much as possible, your survey lines should be minimal. And the survey lines are the lines from A to B, B to C, and so on. They are your survey lines. Okay. Then there should be at least one long backbone line, as I showed you. Okay, there's a backbone line in the survey upon which the surveyor forms the triangle. We saw the backbone, didn't we? We saw the main survey line. All right. We also saw the baseline. All these are the ones we are talking about. You should have them. You should have them. Then the line should be preferably, the line should preferably run through the level ground. Earlier, I said if it is change surveying you're going to do, there's no room for steep slopes. All your steep slopes must be converted into level ground. That's when the leveling type of surveying will come in. So you don't do change surveying on slopes. You do it on level background. That one you have to ensure that happens. Then the triangles formed should be well conditioned. What does this mean? If a triangle is well conditioned, it means that it should have the characteristics of a good triangle. 3 sides. It can be obtuse. It can be isosceles. It can be demiocra. Refi, right angle triangle. All of that. It should be well conditioned. That's what that means. Then there should be sufficient check lines. On the diagram you just saw, you see the check lines. All right. The check line is S2. And then we are, in fact, S1 and S2 are check lines. Somebody will ask, what do we use check lines for? Let me take this opportunity. What do you use it for? The check lines are there to guide you so that your line BD, for example, will not go wayward. Okay, will not get crooked. That is what it does. That is why the name is check line. It helps you to check how straight, how accurate your lines are. So you should have so many of the check lines. And the last one is that your offsets should be as short as possible. This one, I've been talking about it all evening. Your offset should be as short as possible. Because of this point, it is because of this point that we do triangulation. If you go back to the diagram, you'll find that each of the objects is not too far away from a survey line. The 2 houses belonging to Holali and Papa Kwajo are not too far away from line DC. So taking offset there means that the measurement you take will be that short, and that is how offsets are supposed to be. Look at the round shape, very close to line DC, CD, very close. And it is also, a part of it is also close to line BD. Okay, and a part of it is also close to C and SI. So it makes measuring it very short. You don't have to stretch a long tape to be able to measure it. It becomes very short. That is the reason we triangulate. That is the reason we triangulate. All right. And so your offset should be as short as possible. Therefore, the survey line should pass close to the objects. And you can only ensure this happens by triangulation. By triangulating. We are now on slide 39, sorry, where you are now going to book. All of what I'm telling you, I'll go back to the diagram and explain. How are you going to book? You are going to book in a certain book. I've mentioned it here, known as field notebook. The field notebook is an oblong. Oblong means you open it test-wise. You open it from the top. If you want to know what it is, those of you who have been attending conferences, there's something called notepad. Sometimes the pin, it is not pin, it is ring. No, is it a ring or spring type of thing that has been used to bind them. So when you are opening, if it is lying inside your palm, you open it from your chest to the outside. That is the type of book we're talking about. There's a special one for surveying known as field notebook. Okay, and that field notebook, the size is about 200 millimeters and 120 millimeters. So we open it lengthwise, as I indicated. You don't open it in a short way, you open it lengthwise. In thinking any DBA. Then this is how to write. We will go to the diagram and I'll show you how it is done. But you have to rule 2 lines. The 2 lines must pass through the middle. They must pass through the middle. So you have to divide the middle. So the space that will be left on the left should be equal to what is on the right. 1 line, then the other line. Okay. So somebody will say you have divided the book into 3, but not 3 equal halves. The 2 lines that you are drawing from the top to the bottom of the page, all right, should be around 2 centimeters wide. The space between the two lines should be about 2 centimeters or 3 centimeters wide. When you get back to the diagram, I'll tell you what we use that space for, and the spaces on both sides, what we use them for. I'll tell you. So that is it. Then we measure distances along the chain lines are entered within the double lines. That's how you use the double line. The two lines that you drew from the top down, the middle to the bottom. It is in between those two lines that we record all the things that we measure, all the measurements that we take. The example on that page will get you to understand it. Okay. So some of the things I told you are here. That number one, if you are recording in the field book or the field notebook, you have to begin your recording. Begin each line at the bottom of the page. I've already told you that every line takes one page. Every line. But the recording, you don't start the way you start your normal writing. No. This one, the recording starts from the bottom. When you get onto the diagram, I'll tell you why. It starts from the bottom to the top. That is the first thing. Second, you have to leave sufficient space in the field notebook between the chain edges. What are chain edges? All right, I'll show you chain edges. That is, after you have threaded the chain, sometimes it is too long. If you want to wait till every measurement that is taken, it will delay. So you start recording a part of it. Maybe you took 3 measurements and you record it like that. In between them, if you are recording, leave spaces. Don't let them be close together. The figures that you are writing, don't get them too close together. Then you should exaggerate more details. Let them appear big, magnify them, so that at least your diagram, even though you took it over a small area, will look a bit big. And you can only do so by the scale that you choose. If you choose a small scale, your objects will look big. If you choose a big scale, your objects will look small, like that. In that order, I hope you understand this term, because you have done map reading and map interpretation. Okay. Then, clear sketches of all details should be shown in the field notebook. Nothing should be left to memory. Whatever you saw in the field that you think should be mapped, put it inside the field notebook so that you bring it home. You saw a certain road line by the side, very short one. We can't read the Mekai. We do have the better. By the time you realize you have a finance, and you have to spend some other time going to do that. So everything must be represented. And then booking should be done systematically, starting with the side having more details. I'll show you when you get back to the diagram. Okay. So let's move on. We are now on slide 41. Slide 41 has 2 diagrams. It has 2 diagrams. Fixing a station. You are on the field, and so you have to fix the station. Fixing a station on the field. That is what you see there. In the book, both diagrams appear on the same page. In the book, that's how they appear. Now watch something. The first diagram, you see that the whole area to be surveyed is it a mango-like or pear-like? It's a round shape. I hope you have seen it. Correct. That is the whole area. Look at what the surveyor did. He triangulated here, there, and it was done. So the rest of the area he's going to take offset. But if it were me, I would have gone ahead to triangulate more and more. Because from B, you can extend the line to touch the circle. All right. Then you extend the one from C to come and join D where it touches the circle. You have another triangle. You have another triangle formed. The same way, A over there. I can have another triangle at A. The same way, A and D, another triangle can be built there, but he decided to go with it. So what he will do will be that he will take offsets of the rest of the areas. But look at that small thing that is there. Around where we have 3.4 meters. You have seen that one. That's an offset. We see so many of them when we get onto that diagram. So what we are seeing here is just the fixing triangulation, as I mentioned. Okay, the fixing of the stations. It has been repeated on the other diagrams. There are 3 diagrams in a row. All right. I hope we have seen all of them. Another one. So the one that I will be taking you through is not different from what we have here. Okay. That is figure 21 in the book. Figure 21. A typical page of double entry filled notebook. This is a typical page in your notebook. And this is what you did on the field. All right. I'll not waste time on this. I'll take you to the other one and maybe bring this one in. So observe the slide. That is slide 42. I'll tie it in with the other slides. So basically, this is what we call chain surveying. The next thing we shall talk about will be compass survey. Compass. But I want us right about now to go back to that diagram. That diagram, that is part of the chapter 1 that I gave you. So if you wouldn't mind, I hope you all have it. Go to the first set of slides that I give you. And let me show you the very slide where you can find it. I hope you can do that. Slide 19. Slide 19. Let's go. Are you all there? They haven't checked my rule. Let me check it. Abdurrahman Salifu, very regular. Desmond Number, regular. Agbache Beauty, regular. Alex Abba, regular. Ania Tales, regular. Apia Kubi, Elijah, yes, regular. Ellen Oben, the name doesn't sound familiar. Ellen, prove yourself.
Hey, sir, I'm always here.
Okay.
I'm always here.
As for Imanodo, yes. Iman, how is your other name pronounced? Is it Dole or Doi? Then Felix is also here. He's the only one who has been writing. Yeah.
Yes, it's Adolete.
How is your name pronounced? Your surname?
Yeah, Adolete.
So you have abbreviated it?
Yes, but I'm not aware that that's how it shows.
It counts as DOL. Okay,
that's
good.
the Google.
Then Felix is.
The one.
Okay. Felix is always here. Simon is here. Margaret Chere. Anyway. Okay, Maggie, you're fine, sir. Then Nyami William. Mohammed Ibrahim, yes. Yes. Nyame, yes. Then Ilyasu, yes. You are one of 2 people who have been writing their names in capital letters. Pagashoge, Ilyasu, Aloriba. Then Pius Atambiogo, yes. Seshi, his name sounds like my tribe, Seshi. So then we have your course rep, Vanessa. Okay. So I have regulars here. Okay, so any questions so far before we go to slide 19? On the first set of slides, chapter 1. Slide 19, chapter 1. I'm still going to explain chain surveying. Certain things, maybe I forgot to mention. They come up here so that you get all the technicalities. Okay. If there is no question, now let me start with, I hope you have opened that one. Let me start with slide 19, chapter or unit 1, slide 19. Okay. This is a typical page in a field notebook. Note that I have said that in recording in the field notebook, every line, let's say line AB, will cover one full page on its own. Everything that appears on line AB will be recorded on one page, full page, everything. So it means that every line is recorded on the first page. So line AB, line BC, line AC. Then if there are other lines, each of them will be recorded on the first page. So this is just one line. And this line is line AB. This line is what? Line AB. Let's assume. Okay. So this is how it starts. You also heard that before you start the recording, you have to draw two lines in the middle of the page where you are going to write. You have to also know that we mentioned that all the recordings that you will do on, let's say, line AB are the ones that are recorded between the two lines you drew. So in your diagram, I hope the figures are clear. If they are not clear, I'll mention them to you for you to have them. In your diagram, from 7 down there, all the way up to 60, 65 up there, they are lines that were measured on the field. They are lines that were measured on the field. Okay, so the length of that line was 65. It can be in meters, it can be in feet, 65 feet. But the 65 was not done straight away. It was broken down into pieces. From 7, we went to 10. From 10, we went to 13.8. From 13.8, we went to 20 in that order. Why didn't we write it in full? That bam, 65. No way. You don't write it like that. Because I am going to explain it to you. Okay. Now, this is how you start recording. Like AB. You have read your line, everything is set. Bottom of the page. You also heard that we start recording from the bottom of the page. Normal writing, you start from the top, from left to right. But here, we start from the bottom. So the starting point of your recording, you draw a circle. That is why in the diagram, you see a circle there. Let's not forget, every line here, every shape here, every figure here has a meaning. So pay close attention. So you are starting to record. They have started measuring like AB. They have started. So you're also going to record. Before you start your recording, the starting point, the station A, must be marked with a circle. That's why you see a circle there. Inside the circle, you write 0 to mark the beginning of that line. Let's say line AB. Okay. So what do you do next? You start from the very beginning of line AB with your chain. So the leader will hold one tip, one handle of the chain. The follower will start at the starting point A, where the ranging pole is. So the leader will be stretching. He will be stretching. Where he meets an offset, where he meets an object, you have to stop. So on this diagram, after stretching from 0 to 7 on the left, there was an offset there. Check it. That thing that looks like a pizza. Those of you like pizza. I hope all of you have seen pizza before. There's an offset there. It is lying to the right, no, to the left-hand side of that line, line AB, that we are measuring. Are you with me? It lies to the left. And so the principle, the rule says that Where there's an offset, don't continue, pause. So he stretched it from 0 to 7. He met the pizza, I call it pizza, and then he paused. When you pause, the booker will have to record it. And in recording in the double line, you are recording close either to the left or to the right where that offset is, for which reason you are stopping. So the follower stopped at 7. It can be 7 feet, 7 meters. So he stopped there because there was that pizza. And then the booker recorded 7 over there. Now, from where he recorded a 7, the pizza is now going to be an offset. Continue. The pizza is going to be treated as an what? Offset. So he measured from the line, like AB to the left. He measured from like AB to the pizza. And how did he measure? He used the ranging pole as I told you. So he swung it and made sure the ranging pole was standing at 90 degrees. That is why the dotted line leading to the pizza is in a straight line. They are all standing at 90. And when he measured from the survey line to the pizza, he got 6.0. So that 6.0 will be recorded in the field notebook. There was an object there, an offset, 6.0. Okay, so he will indicate the offset, and then he will do the dotted line, and then write 6.0 on the 0 on the dotted line. Because it is not a dot, because it covers some space, you have to take at least 2 offsets. Okay, so after taking that one and finishing the offset, the leader decided to continue. He continued and realized that he was not done with the offset. The offset was still around. So he stretched the chain only up to 3. Now, let's not forget, the recording is done cumulatively. So from 7, he went to 10. It means that from 7 to 10, he measured only 3 feet or 3 meters. And then he got to 10. Why did he stop at 10? He stopped at 10 because that pizza was still there. So he needed to fix it so that he could get the actual size of the pizza and represent it on the map that he will be drawing. So he paused and took an offset at right angle. That gave him 11.0. 11.0. And so he recorded it on the left. But he wasn't done. After recording the 11.0, he realized on the left still, a certain road is there. A certain road is there. Okay. Now he has to show the road. So he made rough sketch in the field notebook that there's a road here. And why on? Okay, how the road looks like. Because when you're doing the reconnaissance, you have to check all this. There's a road cutting through the area he's measuring. So he sketched the road on the left-hand side. Okay. Now, on the ground, what he did was that where he took the 11.0, he continued all the way to the outer part of the road. And that gave him 16.0. So he recorded it there. So when he's plotting, you know that when I get to 10, when I'm cutting like AB or drawing like AB during plotting, when I get to 10 feet or 10 whatever, I have to note that there are 2 offsets there. One is the pizza, one is the outer part of the road. So 16.0, you will measure. Now you are not going to do 16.0 feet or meters. So you use your scale to bring it down. And then whatever you get, you put a dot there. That is the beginning of the road. Okay, so from 10, he's done with every offset here. So you can continue. He's going to continue. From 10, he went to 13.8. Why did he stop at 13.8? He stopped at 13.8 because there was another offset, which now has been given a name as proposed ban. Ban aburupata. A certain upright or shed erected to keep maize or corn. That is a barn. So he stopped there because he saw a barn, which is an offset. Now he saw the barn. Look at where the recording was done. Because the barn is on the right, he recorded it on the right as 13.8. 13.8. That's why the fact that it's in the middle. It's supposed to have been on the right. But you know, computer things and so on. Sometimes you don't get it. If you look at the rest on the right, they are all close to the line. So 13.8. Then he stopped. Now he has to take the barn, the offset. So the offset, he used his cross staff, swung it, and he was able to spot the corner of the barn. So from the survey line AB to the tip of the barn, he had 13.0. 13.0. I hope you have seen it. He wanted to get the actual size of the barn. The actual size. And so where he got the 13.0, he also decided to measure the barn itself. That is why you see 7.25 over there. That is the size of the barn. Then on the edge, on the other side, you see 9.75. No, it is not 14.5. You see 14.5. So he has been able to measure the actual size of the barn so that he can represent it very well when he is plotting. Okay. So when he did that one, he was done with that side. He had to continue. So from 13.8 in the middle, come back to the middle page, the two lines. You see the 13.8. He had to continue. He continued and landed at 20. Why did he stop at 20? He realized that the road was still there, and this time he wanted to have the road properly fixed. This time it was not any other offset apart from the road. So he measured the inner road. You see, every road has two sides. So he measured the first one, it was 7.5. And you look at the lines, they are all standing at 90 degrees. And that is to tell you that he used the cross staff to take the 90 degrees. Then he jumped to the other side, measured from the survey line all the way to get 12.5 for the other side of the road. So you find that in here, on your road, the measurement. Okay, so now he has fixed that part of the road. He has to continue. He continued, thread the chain again to 26.3. I hope it is there. 26.3. Why did he stop at 26.3? Remember the band. He had only fixed one edge of the band, but not the other edge. So when you go to 26.3, he paused and took an offset. This time to the right. So look at where the recording has been done. Okay, where the offset is. And he did that, he got 14.5. So check the difference, how the band lies. The first one he did was 13.0. The second one is 14.5. It means the band is not lying at right angle to the survey line. And all of that he has to show when he's doing the plotting. That's why we take the measurement this way. So now we are at 26.3. Come back to the middle page. Okay, so after fixing the 14.5, he has to continue. He continued only to 30. So it means that from 26.3, all right, he stretched it not more than 4 feet or 4 meters. And he had to stop at 30. 30. He stopped at 30. Why did he pause at 30? Because the road was then curving. The curve of the road was showing. So he had to pause and take the curve. So he used the cross staff, took the offset at 90 degrees, and he had 4.5. 4.5 because it is curving and it is close to the survey line. Then the outer road gave him 9.5. So he has gotten one curve. So at 30, okay, my way 30, let me continue. He continued at the surveyor only to go and hit 33.5, meaning he only stretched it by 3.5. And there was another offset, this time a house to the right. So he paused at 3.5. The booker recorded on that page, on the page where he was recording, 33.5 on the right. So the house, the same way he did with the band, he took the offset from one tip of the house, and that gave him 12.0. He wanted to get the actual size of the house. So he did that one, and he had 6.15. Then the other side also gave him 9.75. He wanted to get the actual size of it. So having done all these, it was good to continue the survey. So from 33.5, come back into the middle. He continued only to go and stop at 37.5. He stopped at 37.5. Why did he stop there? He stopped there. In fact, he could have continued up. But we find that there is a round object over there. A round object. Meanwhile, the other tip of the house had not been captured. Are you with me? So he had to capture it. That is why he stopped at 37. He could have gone all the way even up to 40 and so on before stopping. But that offset was also there. So he stopped, and this time he didn't take perpendicular offset. He took oblique offset. You remember I said there are two types of offsets. There are two types of offsets. All this while we have been doing perpendicular, but now we are doing oblique offset. And that one gave him 16 point, what's the figure? 16.7. Yeah, 16.7. That is the offset to one end, the other end of the house. Okay. Now, when he did that, he thought he could continue. So he started stretching the chain again, only to get to 40. He got to 40, and what was there to the left, the road, the curve was still emerging. So he took another offset, this time at right angle, and that gave him 4.0. 4.0. Okay, that is the inner one. Then the outer one gave him 9.0 at 40. Okay, so he's done with the 40. But that round object to the left is also there. The round object to the left is also around. So what do you think he should do? He took an offset of that one, 5.7, the outer. 5.7, the outer, right? And then he took the inner. The inner, he took it from the other offset he took of the house. You see that after 50, there's 57. So he took another offset of the house, the tip of the house at 57. So the circle, the round object there, apart from the 5.7 I mentioned, the surveyor also took another outer measurement, this time using the oblique offset he took, which gave him 17.5. He used that one as a reference point. So he measured from the outer circle to that offset, and he got 4.5. He measured the inner one from the inner to the offset that he did there, and he got 3.9. Okay, and that is a perfect way to have the round object fixed. So he fixed it. So now back to 50. He got to 50 and he realized the road was still around. He needed to fix it properly. He took another right angle offset, perpendicular offset, and he got 5.0. The outer one gave him 10.0 before he went to 57. From 57, there was no other offset all the way up to 60. All the way up to 60. The road was ending. He stopped at 60 because the road was getting to the end of it. In other words, it was getting out of the area he was surveying. So he stopped there to take the road offset. So from the survey line, he measured the inner one, it was 8.5. The other outer one was 13.5. And so he has been able to fix this road fully. All right. And so he continued. The survey line was not ended. He was yet to end it at 60. There was still some distance to measure. So from 60, he continued all the way up to 65. That is B. Now, the end of every survey line, if you are recording, you have to indicate the line. That is why on the diagram that I showed you, okay, we had all of them numbered A, B, C, D in that order. So this is like AB. The bottom, we wrote 0 and A. Here it is 65 inside, signifying the end of line AB, and B should be written over there at the top. Okay, so on the whole, this is the diagram I have been referring to. We are not done yet. You also see some lines running to C33, to B65, to C49, to B47, and so on. This is telling you that the triangulation was going to the right. Okay, he triangulated to the what? To the right. I hope you understand that. So he's giving indication that if you are 65, the next triangle will not go to the left. The next station will go to the right. And from B to that one, it is supposed to give you 33. But if you are measuring from the end, that is 65, to B, okay, the B that is supposed to be the next triangle, you have 65. So it is with the down there to C49 to B47. That means that if you want to measure from the starting point all the way passing through the next triangle to 65, you have 49. Sorry, 47. But if you are going straight to C, you have 49 in that order. So this is an indication of the direction of the plot. So when you are plotting, you not plot to the left, you plot to the what? To the right, because there will be another line built between A and B and C. That will give you the complete triangle. So basically, this is a summary of chain surveying. Remember all the pep talks I've given, that the recording is done cumulatively, all right, and so on. Remember also one thing that we said. We said that when we are recording, there should be spaces between what we are recording. If you look at the middle part of the line, the middle line where the recordings were done, in fact, the two lines are mainly for recording measurements of distances. You remember that we said there should be spacing, okay? So from 7, there's a space, 10. Between 10 and 13.8 space, between 13.8 and 20 space, like that, all the way up to 65. So this is the end of chain surveying. Any question? We are now going to go on to compass traversing. That is where your mathematical set will start flying. So get ready. But last week, I gave you a certain assignment. I gave you a certain assignment. I don't know how many of you. Oh, no, I said it will be in the slide. I said it will be in the slide. I just gave you the slide. Okay, so I'll not bother you. Maybe next week, I'll take that assignment. And I hope you have seen it. Exercise. Who have ventured to do it? Anybody? You are now 16. I know you'll be more than this, but people are just lazy joining. Others may even not be aware I've been giving you slides. As for today, I promise if I'm able to finish chapter 3, chapter 4 will come today so that you start revising. Okay. All right. So yeah, any questions so far? Uh-huh. Any question? Azima, Eric, or Ajima? How do you pronounce it?
Ajima, Eric.
Ajima.
Eric.
Aji. Yeah, so I nearly got it right.
Yeah.
I used to have a student by name Adima. There's no Z.
Okay.
So Ajima Eric or Ajima Eric.
Yes, sir.
Okay. Do you have any question? You're okay with the explanations?
Yeah. For now, yeah, I'm okay.
Okay, good. So now we're going to look at.
Hello.
I'm here.
Yes. So does that mean if you go to the field, you divide the place you're going to survey, then you now make recording left and right, or how are you doing it? The way you explained it.
Hey. So all what I've said, then it means you didn't understand or didn't listen. Because I said you are not going to divide any field. I said it is just one line, AB, one line. The division is done through triangulation. So every triangle has 3 sides. Each of the sides will be recorded on one line. So all that I explained to you on that diagram is just what you did or the surveyor did on just one line, AB. There's line BC for him to also measure. There will be other things, and that will be recorded on another page in the field notebook. It may have some of these things, something similar. Then you also have line AC to give you a complete triangle. You will record that one also on a separate page from A, then the last step will be C. So you start, if there are offsets, you break into it as you did for like AB, all the way up to the end. So the division is done through triangulation, and the measurements are done as I told you. Recordings in the field notebook are what I am explaining now. Any more? Are you okay? Who questioned? Who questioned?
Yes.
Hello, sir.
Okay, let's. Yeah, hello.
Yeah, mine is not question though, but you said you will try and get a video of some the surveying process for us to at least have it. So maybe before, I think the next week will be our last lecture. So before that, if you can get that for us, I'll be very happy.
I used to, but now, because of this phone and say type, I tried, I couldn't locate any of them. So maybe what I'll do is that I may go online and see which one captures the whole idea and post it for you. I hope that's all right.
Okay, sir. Yes, sir.
So somebody should also remind me that I'll have to give you past questions. Apart from the slides, you also need past questions. In fact, don't go and sit for any paper without having seen past questions or review them. No way. So I'll give you past questions on this. Some of them later, some of them as far back as 2018, when this course surveying proper started with the sandwich group. So the questions that I'll give you will come from the sandwich group. All right. But it's the same course material, it is the same course content, it is the same course tutor, it is the same coordinator. So nothing will change. All right, we are done with change surveying. What Mr. Question I may call, no. We are moving on to compass traversing. Compass survey. Compass survey. And that is the other part of Unit 3. And it is here that we will learn how to do the plotting. And Chibia plotting will start flying. Giddy. And when you're ready with your mathematical set. Compass traversing. And it is here that causes me to delay the plotting. That's why I told you to look for additional time. Yes, Monday. I told you Mondays, Thursdays. This Friday may not be possible because I'll travel later in the day on Friday. So it's only Thursday that's available. But so far, no proposal has come to me regarding when you would want us to have that additional meeting. Because when I start the plotting, Charlie, it is not any small, any better. Why? So compass traversing. Compass traversing. Remember, the compass is a magnetic object. If you go online, you see compass. I have a personal one here for input. I have a personal compass that I use, especially those that I meet face to face, that I use to teach them. So since you don't have it, I suggest you take a look at one of them online. Some of the pictures I show you on the slides are not in the book, but I enhance the slides with online photos. So go online and look at compass. Maybe if you can come try me the it's like it's a pocket size. It is only a little bigger than a big wristwatch, the analog one. So it's a pocket size. This is part of the elementary surveying that every surveyor has to know. When you attend the Ghana Institute for Surveyors, you are not going to be taken through. Somebody's hand is up.
Yes, Doc. Please, if you can put on your camera for us to see your compass.
The camera, pa. Let me try
Yes.
and see. And so how do I position the camera? Okay, whatever. How will that go? How will that go? Okay, give me a moment. Let me try and see how the positioning will look like. I hope you can hear me.
Yes, sir, we can hear you.
Me akra me ohimpo. Me I mean, I said, they all can meet me. Yeah. Camera no ka. Yeah, say okay. I'm switching on. This is my screen. Well, let me see. Okay, me see. Well, now the mama exercise. Why the cat no? You see my compass. Can you see it? Can you see it?
So that's prismatic compass, eh?
Yeah, sure.
Right.
It's a prismatic compass. Once I'm showing it to you, I'll tell you what the parts are. The whole compass, I've opened it. The whole compass looks like this. This is how it looks. This one side of it. In fact, this same one is online. If you search, you'll find it. This is known as a prismatic compass. This one side, let me show you the other side, which is the back. It is like this. Okay, so when you open, this is the handle. This small thing here. This one. Oh, that's the handle. You slot your thumb into it. You slot your thumb into it. You slot it. So like this. Like this. You see where my thumb is? How we can see. Hey. Like this. And then you use this finger, the forefinger. Use it as a stand. So it will sit on your forefinger like this. So now It is sitting. This is my forefinger. You can see it down there. So it is sitting so that it becomes steady. You don't have to let it shake. If it shakes, you get wrong readings. And so those who drink and have their hair shaking, you cannot use this gadget. So that is how to handle it. That is how to hold it. I'm going to open it. This, so if you close it, where my thumb was will fall on it like this. So it is closed. So you can't open. It can nothing can open it unless you remove this. Now when you remove it, you can flip open it. So this is how the cover is opened. You open it. You open it this way. This is how to flip it. Okay, my friends here. You flip it like this. Oh, I wish I had somebody to hold the camera for me. So you flip it like this. You can put this one down, and this one will be standing. That is a standing. The one standing. I'll tell you the pass, and you can also bring this one up. This one can come up this way. Okay. Now what we have here, you see, there's a small lens. I'm using pencil. I went put. There's a small lens over there. I'm coming. Okay. There's a small lens over here. Can you see this lens? You can see this lens. This is what you refer to as the prism. This is what gives it the name prism. Prismatic. This one is a lens. It magnifies the figures. There are figures on the dial here. There are figures here. It magnifies them. And then there's a small slit here. A very small one, tiny one. We call it slit. It is this one that we use to gauge the object. You have to sight the object through this. Now, when you sight the object through this slit, there's a thin line here. We call it thread line. A very thin line on this and that is sitting, that is standing. I don't know whether you can see it. A very like a thread, very thin one. This one, this line, thin line. Okay, that is what you use to gauge or sight the object. So if you look through this, and you can see this, and you can see the object through this, then you have focus on the object. So when that has been done, you now will lower this one. You will now lower the prism this way, so that it gets closer to the face of the compass proper, where the figures are. So this one, you look through it and observe the figures. It will magnify the figures because now you have seen the object. So whatever figure that will show on this line and the thread line here will be the bearing of that figure from where you are standing. So the compass, the face of my compass is like this. It is like this. Okay, let me open it fully. In fact, apart from making a stand, you can also do it this way. This one is also a ruler. Okay, you can open it this way. It is a ruler. This side is a ruler. I hope you can see it. This side is a ruler. It has calibrations and figures here. So if you are using it to do anything on your writing desk, you have a very big writing desk where so many things. So if you are using it, you can use it as a ruler. But it can be open, as I said, to give you a ruler. Now let's see the face of the compass. This is the face of the compass. If you go online, you see the same thing. It has the cardinal points, north, south, east, and west. And then it's 360. So it has all the angles on it, 360. Okay. Now where it is lying, you see the arrow there. That is the magnetic north. It is pointing to the magnetic north. So where it is lying, where I'm sitting, the north follows the arrow. The south is what you see, the west is that, and then the east is here. You see it. And so if you sight the object, the green things there will move. It will move. It will be moving. All right? It moves. Okay? So when you look through the prism, you will see the figure that corresponds with the object that you have sighted, and that will be the bearing of that object. So from where you are standing, so that is my prismatic compass prism. That's my prismatic compass. I hope you have seen something small. And this one is adjustable. You can adjust it. You can roll it, but it has enough. It has enough. You see some yellow line on the figures. Some yellow line. Okay, that is the North Pole. Then the Earth axis. You see the Earth has axis. There's a yellow line here. The yellow lines are two. Oh, the yellow lines are two. One is here diagonal, one is straight. This is what we do when we sketch the globe, the straight one here. But the globe itself, the globe itself has the North Pole of the Earth, something here. You say that between the North Star and then the Earth axis, we have 23.5 degrees difference. So between this and that, we have 23.5 degrees difference. So this is a prismatic compass that is used anytime you are doing compass traversing. So if you want it to stand, this is how it stands. You can let it stand like this, and then you'll be using it to do whatever you want to do. So that is a prismatic compass. I hope you are okay.
Yes, sir. Thank you very much.
Good. As a geographer, and I hope some of you will develop the interest to teach geography at the next level. You need to do much of the work, research, read more, learn more, and you'll be good to go. So that is the compass, prismatic compass. We are going back to theory now, saying that we undertake compass survey using two main kinds of magnetic compass. Two main kinds. We have the surveyor's compass and the prismatic compass. What I have here is the prismatic compass, prism. The surveyor's compass is the one the road contractors use. You mount it on a tripod, very heavy. This is a pocket size. Mine is about all right, so two types. Okay, but nevertheless, compass can be used for many purposes, such as preliminary road and railway survey, as I mentioned, surveys of rivers, streams, and lakes, and for topographical work on small areas. You can use it for so many things. This one is a powerful gadget. Until recently, that was the most powerful gadget for navigation. So every mining company had a compass man. Every ship had it. Every airline had a compass man. But because of modernity, most of these vessels have inbuilt GPS. So it is not necessarily having the compass. Okay. Now there are two main classes of compass traverse. One executed with a large surveyor's compass, the road one, which is mounted on a stand and used in conjunction with surveyor's chain or steel band. The other with a prismatic compass held in the hand and used in conjunction with some rough method of measuring distance, such as pacing, pedometer, or by rope, like that. So these are just theoretical issues which you can easily read. My interest is getting to the plotting. Okay. Now, after you have gone to the field and back, because when you go to the field, using the compass, the same thing. You do measurement, all right, but you take angles, you take bearings. You understand? So when you are back from the field, you have a table of about 4 columns. Table of about 4 columns. I'll give you an example very soon of such a table. Let me go back and see the chapter 1. Okay. How, when you are back from the field, how your thing will look like. Oh, no, that should be chapter 2, not chapter 1. I think we did that last week. Last week. So when we're talking about bearings, I'm showing you a typical way of preparing your or recording in your field notebook when you are doing change surveying. The recording doesn't happen as it does. Go to the chapter 2, last week's own. It is part of what we are doing now. I brought the two together, chapter 2 and chapter 3. Go to slide number 20 of what we are using now. Slide 20. If you have opened your slides, go to 20. This is a typical booking with regards to compass traverse. A typical booking with regards to compass traverse. You have the line or the traverse leg. You have the bearing, and then you have even you have the distance. And I've been here. Oh no, I've been here. I'll show you one. Don't worry. We are azimuth na near come. What a woman also. But as I said, you have 3 columns. The first column is the traverse leg. Of course, if you want to number them, then you have more than 3 columns. You have 4. So 1. Then you have the leg, serial number, traverse leg, or traverse line, or station. Then you have bearing. Then you have distance. 4 columns. If you want to take away the serial numbering, then you have the traverse leg, you have the distance, and then you have the bearing. These 3. That's how to book if you are using the prismatic compass, because you use the tape to take the linear measurement and then use the prismatic compass to take the angles, so that when you come, you are going to plot angles against distance. Angles against distances. That is what you'll be doing when you are plotting. So now we are on plotting and computation of traverse legs. It says that or traverse, plotting can be done directly from the bearings and distances. What are we talking about here? That sometimes you go to the field, your distances are so cute. They are so manageable that you don't need to scale them down. You plot directly. Other times, your bearings are so cute. They are so manageable that you don't have to scale them down. You plot straight. So you can do that. Apart from that, ordinary computations can be done on the distances and bearings on a table. Sometimes the bearing you got was too big that you cannot plot it. So you have to scale it. So you can also scale down bearings, just like you can scale down distances. Okay. Then we use protractor for bearings and your ruler for distances when we are plotting. These are the 2 main things we use. Pencil, yes. Eraser, yes. But protractor is for bearings and your ruler is for what? Distances. Still, you have to choose scales. You choose scales to reduce distances into what? Plottable units. Sometimes you return from the field and your figures are too huge that they are simply unplottable. You use the scale to scale them down. Okay. So that is that slide. Moving on, we have procedure for plotting traverse leg. Okay, so very soon we shall start the plotting. And when you start the plotting, I'll take you deep to page. Okay, let me look at the slide and quickly I'll refer to it. Go to slide 51. This is the one that we are using. Slide 51. You see there, slide 51. That is a typical booking in a field compass traverse work. Okay, so you will see something of this nature. And this is what you are going to plot. So very soon I'll be instructing you to get your notepads ready, to get your compass, your protractor, and so on. Get them all ready for change surveying. That's the change survey for compass traversing. So procedures for plotting traverse legs. Now you have prepared your table. Traverse leg, bearing, distance. Assuming you have scaled everything down. So you are done with the computations and the secretarial works. You are now ready to plot. What is the procedure for plotting? What is the procedure for plotting? First, draw a vertical or perpendicular line to run in a north-south direction. Okay, so straight line from top down. That is the starting point. That is how it will go. Then draw a horizontal line to intersect the perpendicular line in a west-east direction. So you are doing something like north, south, east, and west. I hope you understand that. Okay. So when you are done, when you have done that, which is so simple, you label this setup A or any alphabet that marks the beginning of the traverse leg. I prefer the alphabet A. So this cross that you have done there, you label that whole one A. That is the starting point of your traverse, because in traversing, we also go with the A, B, C, those things. We go with it. And we also do some triangulation there. All right. So you mark it A. That is the first step. I hope you have understood it. This is theory. We shall implement this in practice very soon. You go to the second one. With the aid of a protractor. With the aid of a protractor. I hope you know protractor. Okay. Determine the angle of the first traverse leg. Usually, we call it line AB. We call it what? Line AB. So pick your protractor, that thing that you were using last week. Okay, you pick it, and line AB has a bearing. Look at the bearing and start plotting. Now you have your north, south, east, and west line. So we start off from the north, because in going in circles, the north starts with 0. So that is where you start from. I hope that is clear. So you use your protractor to determine the angle. For example, on page slide 51 that I mentioned, line AB or staging A to B, it has 290 degrees. So you pick your protractor and then you start from the north, 0, all the way you get 290. But remember what we went through last week. If it is 290, it means it is in the third quadrant. So it is 290 minus 180. Therefore, you start from the north-south line. The north-south line will be your baseline. And the stomach, the curved part of the protractor, will face the left. And you read from the outer scale to get the difference and add to 180 to give you 290. Okay, so that is how it will start. So you use your protractor to do this. Then with the aid of a ruler, after you have gotten your 290, you put a dot there as you did last week. Then use your ruler to connect the marked angle to the center of your setup. That is the center of the north-south, east-west line. You join it as you did with the azimuth the other day. Okay. Now, after you have joined it, the end where, and you are not just joining you, please. You are not just joining it. As you rule the line, you are mindful of the length of that line. On page, on that slide that I showed you, the length in meters is 328 too long. So you use scale. When we scaled it down, we got 3.28 centimeters. So you are joining angle 290 to the center of your north-south east-west line, all right. But you are not just drawing any line. You are drawing a line which will measure 3.28 centimeters. So at the end of the 3.28 centimeters, you put a dot there and write B. So now you have plotted traverse leg AB. You have plotted traverse leg AB. At B, you do the same north-south, east and west over there. You do the same north-south, east and west over there. Okay. And now you are going to continue. Okay. The next degree bearing was 200. The next bearing was what? 200. So you're going to start your measurement of your 200 also from the B. Okay, where you have the B. That is where you are going to start it from. And so you tiptoe. Say could do the last point. Maybe as I say it like this, it will appear online. But later, when you start the practicals, you will get to understand. By the time we are done with 2, 3 of them, everybody will be fine. And this is where you have to be. I've told you that there are 2 of them which are always compulsory. It is either the plotting of a traverse or linear scale. So we are now on the traverse. Any questions so far before we move on? As for closed traverse and open traverse, we mentioned it last week. And this falls under adjacent compass traverses. There are 2 types of traverse, closed and open traverse. We saw that closed traverse is a traverse that starts from a point and ends at that same point. The open one, it will start from a point, but it will end at a different point. Those are the 2. And so if a traverse which should have ended at the point where it started does not end there, but rather ends at another point, then we do what we call adjacent compass traverses. Adjacent compass traverses. In other words, we are closing the gap or we are correcting the error, which we shall do very, very soon. Okay, so a typical adjustment is this one. The next slide, slide 47. You will see that we have A, because usually you start from A and then proceed to B. So that is line AB. We have line BC, line CD, line DE, line EF. Then it should have been line FA. That should have been a closed traverse. I see that it didn't close. Between the F and A, there is what? A gap. That gap must be closed. When we get there, we close it. Okay. This is, that gap is known as error closure. Okay. Error or error gap. All right. And so when we have been able to do the plotting, the next thing we will do, which usually takes much of the time, is the adjustment of traverse. Adjustment of traverse. All right. Let's move. Now, in adjusting the traverse, we have a method by name Baldrige rule, which is a graphical method. I'll not take you through this slide. That is slide 48. I'll rather let us do it the practical way. In fact, the book doesn't have slide 48. The course book itself doesn't have slide 48. I composed it aside the book. Okay, so this is all the Baldrige rule. It is part. At the point we will do something like this. And then when it has been corrected, you see the dotted lines as you see on the slide of slide 50. Slide 50, you see the dotted lines. You correct the distance. Remember the one I showed you earlier. Between the F and the A, there was a gap, but it should have closed. So that has been corrected in the book this way. But we are going to do ours. You first go through the plotting. Now I am on page 51. I think I'm going to start here. Page 51. We are going to start the plotting right now. Page 51. Okay, so everybody, get your jotter ready. Everybody, get your jotter ready. Get your mathematical set ready. All right, because I am going to give instruction for all of us to follow. Okay, and that is where we're going to spend time, because somebody will finish, others will not finish. And here, you may not get a second opportunity. It is going to be once or twice. So if you don't try to understand it, well, I don't know. Maybe you will lag behind. So go to slide 51. Slide 51. Are you there? That's a page in the course book itself. Slide 51. So what you see there is a page in the course book. The photo there. I wrote what is by the side. That is what comes along with it. So this is a side proposed for UCC something. Okay. Determine the bearing and distance of line CD after the adjustment of the error. Okay, so there was an error here that you needed to correct. So let's start. If my notepad is ready, my mathematical set is also ready. Very old one, but it is ready. Last week you heard it. Okay, so as I tell you to do it, I'll also be doing it so that we all will be on the same page. We all will be on the same page. And so that will also help me to be able to determine whether you are done or you are not done. But before then, let's do the second thing that you have to do, or the first thing you have to do when you are about to do plotting. Now we are assuming that we are back from the field with this, okay, with this kind of recording in the field notebook. Stations from A to B, B to C, C to D, D to E, E to A. So this one, as soon as you see A appearing twice, then it tells you it's a closed traverse. Okay. So you have the traverse legs. Now, let's look at something. You will find that, as I said, sometimes if the bearings are too huge, you can scale it down. If the distances, that is length in meters, if the distances are too huge, you can also scale them down. Here, we have 3328.02 meters. There's no paper like that. This one is even more than 100-meter race, 320. 100 meters is 100 meters. So you cannot get any paper to help you do this. Therefore, we have to scale it down. You have to choose a scale that will help us bring it down. Okay. So let's try it. That means that we will have to draw another table. So you copy. Because in exam, you have to do that. So you copy the table, station from A to B. As for the bearings, you leave them. But the length in meters, that is where you are going to work, because you cannot plot them. Look at the last one, it is 365 meters. There's no way you can plot this. And so for the length, you have to choose a scale. Your scale shouldn't be one that will give you short distances. It should also not be one that will give you long distances. No. So to save time, let's try 1 centimeter to 100 meters. Let's try that one. Let's try that one. 1 centimeter to 100 meters. So what you will do is that you divide 328.02 by 100. What do you get? Then you divide 195.36 by 100. And so you copy the whole of the table and create another column. That column will be reduced length. That will be the heading. Reduced length. So this is what you do. You will not do the calculation on the table. You do it somewhere else. And then only write the final answer under the reduced length. So AB, 290 degrees, length in meters 328.02, then reduced length. After dividing it by the scale, 328.02 divided by 100. Whatever you got, you write it there. In examination, because of uniformity, you may be given this scale. The scale will be given to you. So 328.02. What is the answer? Thank you.
3.28.
Okay, so 3.28 centimeters. You have to add it. All right. Then you go to the second one, BC. 200 degrees, 195.36. So this one too, you divide by 100. What do you get? So under the reduced or scaled distance or diagram or length, you write for the second one
1.95.
Okay. Then you go to CD. Bearing in degrees is 190, and length in meters is also 195.36. So the reduced or the scaled length will be what? Same as 1.95. Okay, let's go to DE. DE, bearing 112. Is that correct? Yes. And then the length in meters is 225.56. So what will be the reduced length or the scaled length? You get
2.25.
2.25 cm. And the last one, EA, 30 degrees, 365.64
3.66
in meters. So you get 3.66. Here, don't round them off because it will spoil the whole soup. Leave them in their decimals and try and get the decimals on your ruler. Okay, so what we have just gone through is what we refer to as the computation in the office, calculation in the office. Sitting by your table, that is what you will do. All right. So you have gotten all the ingredients. Your sketch pad is ready. Your mathematical set is also ready. And your table is also ready. And so you have to start your plotting. You have to start your plotting. When you are starting the plotting, one thing you have to know, because you have a plain page where you are going to do it. Where would you start from? Top right, top left, center, corner, bottom left, bottom right. How would you determine where to start from? Because sometimes if you don't position it well, by the time you are done, some of your lines will go outside the paper, depending on where you started from. Okay? Sometimes you have to start from maybe top left or top right, like that. Other times you have to start from the bottom and go because of the bearings. So normally the advice is that do a rough sketch. Do a rough sketch. And the rough sketch goes like, okay, I am going to plot. And you know the starting point. You do the north, south, east, and western. The first angle you are supposed to, bearing is supposed to plot is 290. You know 290 is in the third quadrant. So if you start from the top left, you'll be in trouble. All right. So you bring it somewhere to the middle. where you'll be able to plot 290 and the distance, that will be 3.28. Okay. Now, at 3.28, you do the same cross. The same cross. What work now, you know? That 3.28 is a measurement distance. So you measure, you put a dot there and do the cross, the north, south, east, and west. There, right on the dot. If it goes over the dot, you get some of your measurements wrong. So you do it right there. The next one you're going to plot is 200. So where will the 200 be? 200 is still in the third quadrant. Are you following? And we are going to plot 1.95. So it tells you that if you did the thing, started the thing close to the margin, left to the left margin, you'll be in trouble because the first two are in the third quadrant. So 200 will give you the third quadrant, but it will come down a bit. So 200 after 180, 200. Then where you have gotten to 1.95 by your ruler centimeters, you put a dot there and you do the plus. Let the center of the north, south, east, and west be the dot that you place there, which marks the end of the 1.95. Yeah, rough sketch. Don't do it. Yeah, I'm only trying to let you know how you can start by doing rough sketch. Now, when you have done that, the next one is 190. 190 is still in the third quadrant. I hope you are following. 190 degrees is still in the third quadrant. So it means that your diagram should go as much as possible to the right margin. Right. So that your 190 degrees, which will be also 1.95 centimeters, is also still in the third quadrant. Just that it will come down a bit. So when you have constructed 1.95 centimeter line, wherever the 1.95 line will end, you put a dot there, and then the next one to construct is 112. 112 is less than 180, so you are in the second quadrant. So you construct 112, where your 2.25 will end. You put a dot there and do the plus. Okay. Then the next one you have to construct is 30. 30 is in the first quadrant. All right. So that one will take you up. That one will give you 3.65. Okay. Then you mark. So over rough work. And on if you know how to do it, you not keep long. So that to give you a fair idea as to where you have to start your plotting. Whether top right or top left or middle or where. Okay. So that is it. From what we have just gone through, I think it will be better to push it the top a bit, but getting closer to the north, to the margin, getting closer to the margin of your paper. But you see, you have a bigger paper, so maybe to no worry. I'm using A4 to do this. Okay. Now let's start the actual work. Pick your ruler. Say any economy, my instruction I know afa. Pick your pencil. Pick your ruler. Pick your pencil. I hope you have done that. Okay. Now, with the ruler, with the pencil, you are going to construct a line, perpendicular line, standing at 90 degrees. And that line should be about 2 centimeters long, 2 centimeters per hour. Okay, for the sake of beginners, let's make it 2 centimeters long. So do that. And so you are going to maintain the 2 centimeters all throughout. Construct 2 centimeters. Okay. Now, perpendicular line. You are going to construct a horizontal line to cross the perpendicular line. Also 2 centimeters. also 2 centimeters. What no, because after the 3rd unit, the 5th unit is cartography, where we shall learn some of the skills and so on. There's a particular topic my chief examiner likes, Papa. So you have now gotten your north, south, east, and west. Don't number them north, south, east, and west. You are not doing that. So label that place anywhere. Put A, alphabet A over there. Okay. Now you have it. Pick your protractor. We are going to construct the first one. The first bearing. The first bearing is 290. So as I showed you last week, 290, you have gone beyond 180. So leave the 180 alone. Put the base of your protractor on the north-south line. And let the perpendicular line, the 30-degree line, lie on the west line. The line that is west. I hope you know that one. The one to your left. Let it lie there. But before then, you have to do your computation. 290 minus 180. What degree, what are you looking for? 290 minus 180 will give you what?
110. 110.
It will give you 110. 290 minus 180.
290, 180. No.
110.
You have 110.
Yeah.
Sure.
It's 290 in the 10th quadrant or 4th quadrant. I hope.
Okay, at this answer, all of you can put your microphones on so that you'll be quick if you are having troubles, so that you can communicate quickly.
Yeah, please, 110.
So 290. Okay, 290 minus 180 will give you. Okay, so let's have my hair. Hey, 290. So it means you are in the 4th quadrant. So 290.
Yes, sir.
Oh. You are in the 4th quadrant.
Yes, sir.
In the 4th quadrant. So it should be 270. So I think it will be 290. 290 minus 180. Oh, it will be 270 minus.
It will be
290 minus 270. It will be 290 minus 270. Please, you can pay attention. It will be 290 minus 270. So you get how many? You get 20. Eh? Hello.
Yes. 70.
You get what? 20, correct? Okay.
So, hello, sir. So, sir, this one, can't we do it a whole circle? Or we should do it quadrant?
Yeah. Now you follow what I'm doing.
Okay.
You let's follow. So you are now operating in the 4th quadrant. Now in the 4th quadrant, how do you get your 20? To add to the 270 so that you have your 290. I hope you are following me. How do you position the protractor? As I said, as you do it, I'm also doing it so that we all will be on the same page. So this is what you do. You are looking for 20 to add to the 270 so that you get your 290, correct? So you put the baseline of your protractor on the east-west line.
East-west line.
And then your perpendicular line, the 90-degree line on the Oh, pay attention. That's why I said, if you don't let us follow one after the other, then we are working answer. So the protractor's baseline should be on the east-west line. And then the perpendicular line of the protractor should lie on the north-south line. I hope you have gotten it. Who is lost? As I said, at this juncture, you can unmute so that if you are facing any trouble, you can quickly chip in. But I don't want noise at the background or side talking. The only talking that should come, that should be heard, should be one that is coming to the platform for all of us to respond. So having done this, you can read using the outer scale, 20. So you see 20 there. You put a dot there. You put a dot over there. Done? 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 Who is lost? Is everybody on the same page with us? Okay. I take it that because I said let your microphones be on now, but don't let there be noise at the background so that you all can communicate. Okay, now with this dot in you are now going to pick your ruler. You pick your ruler. Okay. Now connect the dot to the center of your setup A. Connect the two. Let the beginning of the ruler lie on the center of your setup A. And let the ruler pass through the dot. Let the ruler pass through the dot. Okay. If the ruler is passing through the dot and the beginning of the ruler is at the center of, oh, I told you I don't want noise at the background. If you know you are in a noisy place, just mute. That's all. So with the ruler, the beginning of the ruler, the starting point of the ruler, at the center of your setup, the class you did earlier, and the other side also touching the dot. Okay, you can now measure 3.28 on the ruler, and so you find that your 3.28 may not even reach where you place the dot.
Yes.
It will not reach there, but it will have to be, the two must be on the same line, the same plane. If it doesn't fall in that dot that you placed there earlier, you are wrong. So let it pass through. Let the beginning of your ruler also lie in the center of your north, south, east, and west setup. Okay. So with that, you can now measure your 3.2 and then place a dot also there. As soon as you place that dot, you forget the first dot. Now that dot, that second dot you have placed there is standing for two things: 3.2, 3.28, and 290 degrees. That is the line. Okay. Now at the end of the 3.28, do the same setup, the north, south, east, and west over there. Make sure that the point. Yes, I'm here to talk.
Please, I want to get it more clearer. The first plotting, which is 290 degrees, is in the fourth quadrant. And so we are subtracting 270 from the 290. Then we are left with 20 to look for. The way you say we should position the compass, you talk about the position the protractor, the outer protractor. When we are using the outer protractor, according to you, say we should position it on the north and the south, where the protractor is pointing towards the eastern direction. The western direction. So am I right?
No. Then you didn't follow. That is why I said this one. It goes with the instruction. I give one, you do it. That was when I thought it was in the third quadrant. But later, when myself, I remember that it's in the fourth quadrant. I said, and I gave vivid this, and you have gone past that stage, Grant. I'm surprised. Okay, so you are looking for 20. Okay, to add to 270 so that you get your 290. So what you do is that you use the east-west line.
Okay.
As your base. And then the north-south line becomes your perpendicular. So the perpendicular line, the 90-degree line on the protractor must fall on the north-south line. All right? And then the baseline of the protractor must fall on the east-west line. Then you read the outer scale, you will see 20 there. You place a dot over there. That dot added to the 270 will give you 290.
What notice there? What notice there?
Okay, so that is where we are. Then we are now looking for our 3.28 line. So you pick your ruler, you put the ruler, the beginning of the ruler, the 0 point at the center of the north-south, east-west line that you did. That is point A, the area. You put the beginning of the ruler there at the center pair. And then the other side of the ruler, you make sure it is falling in line with the dot, the 290 dot that you place there. Okay. Now, having done that, you now can see on the ruler 3.28 centimeters. You put a dot there also. So now you have two dots. The first one, as soon as you put the second dot there, the first one becomes useless. It was only to guide you to get your 3.28. So the first one is no more in use. So the second dot that you have placed there, in fact, elsewhere, you have to even erase the first one so that it doesn't confuse you. Now that you have that second dot is the 3.28 centimeter dot. It is also the 290-degree line, 290-degree dot. So having gotten that second dot, you pick your pencil, use the ruler, connect that dot to the center of your point A. As if you are drawing azimuth.
Well noted.
Okay. Now, that is done. After drawing this line, you are now going to do the same north, south, east, and west steps. Again, making sure that the dot that you use to draw the 3.28 line is lying right at the center of the new north, south, east, west line that you are going to use. Please, there's noise at the background of somebody's listening.
Ima.
I've told you, if you think there'll be noise, just mute and just follow the steps. So, do the north-south line and the east-west line, making sure the dot that you have used to draw the line is lying right there in the middle. Now, Have you done that?
Yes, sir.
Okay. So with that done, please, your line shouldn't be too long. About 2 centimeters, you'll be fine. Maya.
Please, let's meet.
Maybe,
Let's meet.
maybe it's not aware. Unfortunately, I cannot mute him. Okay, I've muted him. All right, now let's go. So, where you have done, where you have done the second north, south, east, west line, right? B, alphabet B, alphabet B. Uncle. Okay, thank God. So you have been able to plot A to B successfully. That is A to B. Let's move to B to C. B to C, we are plotting 200 degrees. 200 degrees against 1.95 centimeters. So first, take your protractor. 200 is more than 180. Okay, so you need only 20 to add to the 80, 180, so that you have your 200. So this is what you do. 180 is there already. Therefore, the base of your protractor should lie on the north-south line. The perpendicular on your protractor should lie on the west line. At this position, your protractor is well set out. And so you need only 20. You can now read from the outer scale. You can read from the outer scale and you have your 20. You put a point where you have the 20 and take away the protractor. Take away the protractor. Okay. Pick your ruler. Put the beginning of the ruler at the center of B. At the center of B. And let the other side of the ruler touch the dot, the 200 dot, the 200 degree dot that you have placed over there. I hope you are there.
Yes, sir.
Okay, good. Now over here, you are looking for 1.95 centimeters. That's about 2 centimeters. So look for 1.95 centimeters on that ruler, making sure that it is still lying at the center and through the dot that you place over there. So again, you have a second dot over here. That will be 1.95. Done? Done?
Yes, sir.
Okay. So take away your protractor with your ruler. Rule the line to pass through the second dot. Making sure it is up to 1.95 and you can erase the second dot, the first dot. You can erase the first dot over there. Okay. You can erase the first dot. Okay. So with the second dot having been used to construct 1.95, we are done. We are going to do another north, south, east, and west at the place where we just did the 1.95 dot. Making sure that that dot is lying right at the center of the north, south, east, and west line. Making sure that it is lying right at the center. Captured? And now you can write C over there, capital alphabet C. Alphabet C. Okay. So now you have plotted traverse leg BC. You have plotted traverse leg BC. Okay. Now let's go to traverse leg CD. Traverse leg CD is 190 degrees against 1.95 centimeters. So go through this on your own. Let's see.
Sir, please come again.
I said you are plotting traverse leg CD. And the bearing is 190 degrees. And the scaled distance is 1.95 centimeters. And I said, go through it on your own. Let's see whether you can do it. You first start with the bearing. You pick your protractor. It is 190. So you know 180 is off. Okay. So you use the north-south line as your baseline. And then the west line as your perpendicular line. Then you read, you get 10. You add 10 to 180 to get 190. So where you see 10 degrees, you put a dot there.
So 10 the third quadrant.
There is more than 190, 180.
Yeah.
To be in the third quadrant, yeah. Now over here, the only skill that is important is how to orientate the protractor, how to position it, and how to know that I have covered this. So if I get this to add, I'll get it. I don't think it is even difficult. Okay, so now you have your dot. Pick your ruler. Make sure put the ruler, the beginning of it, at the center of C. And let the ruler pass through the 190-degree dot. Let it pass through it. And as it passes through it, you are going to look for 1.95 centimeters on the ruler. And over there, you place a dot. So again, you have two dots. You have two dots. Make sure there's a dot. Having placed the dot, you are done. You will now come and do the north and south, east, west setup also there. You do that one also there. And when that one is done, you write D over there. Make sure the dot is lying in the middle of your north, south, east, and west. Make sure that happens. So after you have done the north, south, east, west, you write D over there. Who is lost? I hope all of you, is it 14 or 15 of you, are paying attention? Okay. So let's move on. We have done A to B, B to C, C to D. We are going to D to E. D to E is 112 degrees. And your scaled distance is 2.26 centimeters. So 112 is less than 180, but more than 90. Okay. 112 is less than 180, but less than 90. So it is going to be 112 minus 90. What do you get?
22.
You are looking for 22, correct? So how would you position your protractor?
On
Use
a
the
north-south line.
no. You said you are looking for what?
22.
You are looking for 22.
Yeah.
So that we get 100 and what?
112.
112. Okay. So this is what you will do. You use the east-west line as your base. And then the perpendicular line will fall on the north-south. Okay. So at this position, you are well set out. Therefore, you read from the outer scale all the way up to 22 and place a dot there. From 0 to 22, you place a dot there. Now with this dot, the same way, you pick your ruler, put the beginning of the ruler at the center of D, and let the other side also pass through the 112 the 112 dot that you place over there. At this position, Sally, there's rest at the background there. At this position,
Honorable Elias, please mute.
okay, I've muted him. At this position, you are going to look for 2.26 centimeters. So on your ruler, if the ruler is at the center of D and it is passing through the 112-degree line dot, then look for 2.26 centimeters on that ruler and place a dot there. Place a dot there. At this juncture, you have two dots. So discard the first one. Okay, so connect the center of D to the second dot that we just placed. Done?
Yes,
all right,
sir.
I hope it is done. Okay. So over here, you can do the north, south, east, and west thing again. Where you have your 2.26 line. Make sure that dot is passing through the center of your north, south, east, and west. Okay. Now over here, after you have done the cross, the setup, you write E, alphabet E, as in Ima. Hey, Vanessa, I'm in the whole day. Are you there? Vanessa?
Doc, please, I'm here.
Okay, good. That's good. That's good. That's good. You are following, aren't you? Okay.
Doc,
So
I'm
you have
following,
done.
but
Okay. Okay, that's good. But no, this one, it is one at a time. So if you don't, you see that when I say one thing, I pause before the next one comes. If you don't follow continuously and you are distracted even 1 second, you're off. So where do you have issues? Vanessa. Do you have issues anywhere? Okay. Now we are at E. We have one last one to plot. That is E to A. E to A is 30 degrees. 30 against 3.6 against 3.6. Okay. So pick your protractor. Pick your protractor. And how are you going to position it? Use the north-south line as your base. And let the perpendicular lie on the east line. Okay, at this position, you are good to go. So you see 30 degrees over there. You place a dot. And then protractor, or we in Juma. The work of the protractor is done. Okay. So now what you're going to do, as usual, pick your ruler, put the beginning of the ruler at E, at the center of E, and let it pass through the 30-degree dot. Now, as you are here, you are looking for 3.66 centimeters on the ruler. So mark 3.66 centimeters on the ruler. Okay. Okay. So 3.6 is well marked. That's way on the ruler, on the paper. So well marked. Now you have two dots. Discard the first one. And then rule a line joining the center of E to the 3.6 line dot you just placed over there. So at the end there, that should be, that is the end. No more north, south, east, west line. No more. However, you can also do it. Nobody will penalize you. Okay. Now over here, you can still do the north, south, east, west. Nobody will punish you. Okay. So you will find that instead of landing at A where you started from, because this last one should have ended at A, you find that it is ending rather at another place. Have you seen that?
Yes, sir. Inside.
Yes, sir.
Okay, so between the A, the original A, the one you started with, now another A has been formed here. The one you just plotted, that one is also A, but that one is A prime. So put apostrophe on top of that A. Anytime a traverse doesn't end where it started from, where it ends would take the same alphabet as the beginning. But where it ended will have an apostrophe, a prime at the top. So we have A and A prime in the diagram we just drew. Plotting over. Now compare what you have plotted to the slide that I gave you. This same thing has been plotted on the slide. That is slide 55. Are you there? Have you seen it? Compare it to what you have done. Have you seen it? What is the difference?
Yeah, sir, I have no difference.
So you're on your way to becoming a cartographer. Yes. This is the cartography version, plotting. So you have successfully plotted your first traverse legs. Time is almost up. As I said, I may need more time, maybe no less than 4 more additional hours, because let me draw your attention to this. Between A, the original A, and A prime, the gap there is known as error of closure. The gap there is known as error of closure, or the closure gap. That is an error. It was not caused by you, especially when you have done what you have to do correctly. It was caused by something else. You call it local attraction, that we shall look at very soon. But with regards to the plotting, this is how it should be. It should have ended at A. It didn't end. So you have A and A prime. The gap between A and A prime is known as the error of closure, or the closure gap, which we have to adjust or correct in future. Okay, so that is it. With this basic idea or knowledge, at least now you have an idea about how to plot traverse. Okay, I think you can get some more examples. I'll bring you past questions so that you look through and see whether you can get some more examples to practice with. Last year when I was teaching them, I gave one of such plottings to them, made everybody plot, and then forwarded it to me. Everybody plotted and forwarded it to me. I think on the platform or so. Your name, everything is there, so that I'll see and mark. Okay, so that is all we can do for today. That's all we can do for today. When next we get time, it can be tomorrow. No, it can be Thursday, or that no, we can see the meaning. It can be Thursday only. But after this week, I can get Monday for you. That will be God willing next week. I can get Monday for you. I can get Thursday for you. I can get Friday for you. All right. So that if you so wish, and these are the vacancy where I will get to, and the allotted time is over, I will end it. Okay. So look for additional time. Let me come in so that you do it. You do another plotting, but for now, go and practice. Do your own practice so that you become more conversant with plotting. Now, one thing about learning is that as soon as they teach you the thing, don't go and rest. You can use the same figures and go through it again without anybody instructing you, and see whether what you will do and without instruction and what you did under instruction will match. You can do it and do it again, just so you can become perfect. And there is nothing different. No, that is how the plotting goes. The same procedure, the same formula. Nothing changes. So if you're able to grab this one through the constant practice you do, next time when we start another plotting, you will not have any issues. I know how busy some of you are. I know that some of you are more than busy, so you will not get time to revise. I know some are also not joining the online. Some of these things, they'll struggle to do it. And once I'm able to take you through, I'll inform my chief examiner, because you ask me where I was able to reach with you. I'll inform you that I've taught them plotting. I've taught them skills, how to plot linear scale. So bring one of them and it will come. You get a point. So learn and learn it good. And it is going to help you yourself. It will be outrageous to hear that you have passed surveying and cartography, but you cannot do simple plotting of traverse or linear scale. Okay, so go and do further practice. That is all about it. I'm done. Yeah, somebody's hand. Yame, your hand is up.
Concerning the time that you want, you are saying that weekend you will not get time. I don't know. In the morning, I don't know if my friends have a lecture, but in the morning, Saturday, some of us we don't have any lecture. So if the other day you said
No,
that
Saturday.
like
Uh, I'll have
7 a.m. if you
I
have
have
taken
I
up.
have a funeral.
Saturday, some of us have lectures. So
In the morning.
Yeah, Saturday I have a
in
funeral.
the morning, we have.
Yeah.
Okay.
We have up to the evening. Some
All
of
right.
us
So
have.
I think one fine Monday evening, one fine Thursday evening, God willing, we can sit and do
Okay.
this and clear it. At least if I get 4 more hours, we will be able to finish. Now, what is important now are the 2 plottings, one of which we have just started. Apart from that, nothing more. If we are no the rest, everybody will be okay with it. Vanessa, your hand is up. Okay.
Thank you. Doc, please, I'm pleading with you.
Uh-huh.
Code the something last block. We don't want it to repeat itself again. I'm pleading. When you give the questions to them, at least when they type the question, please request it before we write the exams.
What happened last block?
They give it.
Last block, that was map reading, and
Uh-huh.
we couldn't see anything on the paper.
Yeah.
The landmarks were not clear, wasn't up to scale. Some of us were even asked to do it on phone. Later, nobody had it correct. We have to write petition to code, and we don't know how to. Not just myself, everybody experience it.
Who
So
taught?
please,
Do you remember the name of the one who taught map reading?
Nana
yes, I
Kinsel.
do remember.
Nana.
It's Kinsel.
The
Also.
He's the course coordinator.
Okay.
Yes, the coordinator.
He's the coordinator for surveying too.
Uh-huh.
Okay. Okay, I'll talk to him. I'll call him tomorrow and
Hello,
talk to him.
hello, sir.
Yeah, I'm here.
Hello, sir.
I'm here, please.
Hello, sir.
I'm
This
here.
issue, we reported it as Sunyan Center. And what happened was the problem was not coming from him, but it was coming from the exams unit. They rather did photocopy instead of making a colored photocopy for us. And they did black and white. They called him that very day and he explained. So the problem was rather coming from the exams unit. They rather did
But
black and white
still,
photocopy.
I'll discuss it. I'll discuss it with him. I've
Okay.
worked with him all this while since 2018 that way. So yeah, I teach this course and sometimes map reading also under him. So I'll still discuss with him. As we speak, I'm teaching surveying also with a sandwich student. They're also reading surveying this semester, and it's the same person. So I'll discuss with him so that at least if something else can be done in terms of looking at other areas you did well, then it will happen. I'll talk to him about it.
Thank you.
All right. So on that note, we come to the end of our meeting. Thank you very much.
Hello, sir.
Yeah, I'm here.
Please, just a quick one. In regard to the plotting of the length, like the point and things. If let's say there is a little bit, maybe not accurate, like you are not exactly. Oh, please, who is that? Abdullah, please. Hello, sir.
I'm here.
And so I'm talking. I'm more concerned about the plotting after maybe you've gotten your angles, and then you are plotting. Maybe putting the ruler and then trying to plot the distance, the length, the distance, and then sometimes because the point something within our distance is difficult to get the exact point. Let's say 3.66. Those kind of small. Maybe there's a small difference between that. Will you be penalized for those small mistakes? Maybe
not really. For every practical work, we give some margin of error. Maybe 0.2 or 0.3, depending on what it is. So if all other things are okay and it is just the points and so on, you will not be far from right. Your diagram if you followed all the protocols, all the rules, your diagram will not be too different from the correct one. So you will not suffer any much. When we are marking, we also plot, and then we put ours on a stencil, the translucent paper. Is it transparent or translucent? We put it on yours to see how it falls in line. Sometimes it is about 0.01 difference. That one is nothing. So everything is given to you. So you learn the intricacies, okay, the basics, and let's go through it. If it happens that yours is just a few millimeters away from the correctitude, you will still be given the mark. All right. So don't worry.
All right. Thank you, sir.
Okay, Willie. Oh, the same person. Okay.
Yeah, sir.
Your hand was up.
I'll be happy like we settle the day that we meet. I'll be happy like we settle so that we all get to know and we get ready for it.
Well, I had wanted it to come from you, but it appears that communication is not coming. As for this week, the only time left will be Thursday because tomorrow I have surveying with sandwich students from I think 5:30 to 7:30. Theirs is 2 hours, 5:30 to 7:30. So today the only time left this week the only time left will be Thursday. All right. If
So
Thursday
I will be on Thursday
I'll
the
be
same.
available. The same time I'll be available.
Okay, so if the rest
God
can
willing.
so that Thursday will meet from 6 to
All
9:30.
right. So anybody who has
God willing,
issues with the test,
God willing,
if you
Thursday,
have
dog, we are.
all right, very good. I'll be around. I'll be available.
Thursday.
So
Okay.
let's make it. Yeah, let's make it a deal. Thursday. By that time I would have uploaded the fourth chapter. The fourth chapter it's only the skill that is there. The rest will be reading. After getting the basics and all, you do how much they are. The rest, plotting on and I'll be here. So I'll meet you on Thursday for us to do some more plottings and try and see whether you can correct the error. But between now and Thursday, please don't rest. Practice with these um, figures that we have just gone through. Once you're able to capture and become conversant with it, nothing more, nothing less. Any other figures you'll be able to plot. That's all. All right. So I wish you a good night and may good Lord keep all of us safe and sound till we meet again on Thursday. Bye-bye.
Bye.
Bye.
Bye.